Hey guys, we are recording this video session. So you have a recording at the end of the 3 hours from right now. And so the session is being recorded. This is my screen sharing starting. You are able to see me, hear me. And so we'll just begin with a quick recap of what we have done up until now. We have done, basically, if I discuss the definition of cloud computing, we had to have this idea of, software as a service, infrastructure as a service and platform as a service. And we were, digging through the three aspects of, compute, storage, and network. That's where we are kind of sort of like, moving around. We discussed this, and we kind of sort of discussed also this, and they came back here with, the CDN aspect is kind of both network and storage. And come to think about other aspects of storage like NAS, it is by definition network attached. And also SAN, it is also network attached. So all these storage elements, even though they are traditionally classically defined as storage, they have a network component to begin with. I mean, that's how the nature of storage is, unless you are direct attached storage. You attach the disk directly to the computer, which is also the case, but very, very less in usage. Most cloud deployments are directly connected to some kind of a storage area network. So it is network and storage together, and some compute. So that's what, and compute aspects come into play, where most of us did the exercise of S3, and we created a bucket, and we put objects in the bucket, and we created a very, very simply silly looking site, and felt happy about instant gratification. But then we quickly expanded this, and we said in the S3 bucket that we have, let us create a somewhat half decent looking site. And then we have a canonical name set that we pointed straight to the bucket. And then we felt happy about its availability and the kind of ease of create, and just using some tool like S3CMD is an open source tool we used. Amazon has AWS command line interface, which you can also use, by the way, the same method of the synchronization that allows us to store whatever files we have in a folder. We can just send all the detail to a bucket using this tool, or we can use this command line tool, or there are ton of methods. One of the methods that I don't like, but I'll show you because I have it apparently, is this thing called Mounter. Just random software that allows you to connect to a variety of storage solutions. It's not fancy. It's just that you have to have this software, and then you provide the access key and secret key and a mount bucket point. So here you can name the bucket that you have, for example, whatever that, my blog.domain.com or something like that. And this is your US East one or West one, or whatever endpoint that you might have. So you specify the endpoint, give it a connection name, and mount the bucket as a disk right here in your computer. That's the capability that this software provides. I'm deleting that connection, but this software is available for like $2, something like that. So that's one. There are many, many such examples. The commercial software that will let you connect your buckets. Like I mentioned here, the variety of choices you have, FTP connections, or if I just get to the list, FTP connection, Dropbox connection, Amazon bucket connections, Google Drive, OneDrive, OpenStack, Swift connection, Box and Backblaze, and a bunch of other service providers. So this is just one example. But again, this is not open source. So the open source solution that I actually like is available from a Switzerland team. I think it is called cyberduck.ch. And that tool is open. And the source code is available and downloadable, and it works on Windows and Mac and all that. And so this is what it looks like, and it lets you connect Windows, Macintosh. It's available on the App Store. It's on the Windows 10 store, and it's a decent tool. It's a UI visual, and so you can drag and drop files in between FTP, SFTP, WebDAV, Amazon, OpenStack, Backblaze, Microsoft Azure, OneDrive, Google Drive. So basically all the storage locations you can think of. These are visual tools. And so if you like visual tools, you can use these guys. This is free, open source. So that's CyberDuck. Okay. The idea that we continue is that when we did the next thing, which is extending this CNAME idea direct going to the bucket, we expanded that homework further. What we then did is chose our CNAME, and instead of asking it to go straight to the bucket, instead of going it here, we said, you know what, we will put a content delivery network layer around on top, and then map the name to the CDN endpoint. And let this CDN actually mirror whatever is there in the bucket. So that's the point that we did, and many of you have actually completed this homework with having your canonical name defined, your custom website defined, pointing it to the content delivery network, which in turn is mirroring what you expose from your bucket. Now, while doing this, in the last session, live session, in a 3-hour-long session, one thing that I did was, I think, my mistake. And I would like to point out to you as to what that mistake was. What I did was that I was not super clear, very, very crystal clear about what I wanted to communicate, which I think I have written down somewhere in 2012 in a blog post. And I did not call it out explicitly, and that had led to some of the issues that some of you actually struggled, and some of you had strange issues pop up from Amazon consoles. I'll demonstrate those issues to you as to what you ran into. Some of you did run into this issue. Like, for example, I'm going to log on to Amazon. I log in, and then I sign in, and then I put in my token right there, and I go inside, and then I go create a CloudFront. And in there, I say create distribution and get started. And here is the point of confusion right there. The origin domain name. Now, when you are at this screen, Amazon gives you this easy drop down. Very, very easy. Just say Amazon bucket, you select the bucket you like. And if you have a load balancer, you select the load balancer you like. I don't have any, but I have lots of buckets. So you can select whatever you like. And then that's where the problem starts. Now, this is a design issue, which I think is an issue, but Amazon may not agree, is that if you want to create an origin, like I want to, and put a different point right here, it doesn't prompt the actual value that should go in here. And that was kind of cryptic way of describing what I'm telling you about. So what I will do is give you a specific example as to what the root of the confusion arises from, which actually is partly caused by Amazon and partly by me in my not clear description. So I'm clarifying that. Is like this. I'll go to my virtual machine, and I will say, start this thing and run some example that you might have already there. And some of you probably know this already, that if you have that Octopress thing running, like I'll show you as soon as it starts, you can double click the index file, and it should kind of sort of show you some site-like look and feel. What I said is site-like look and feel. It doesn't actually show you the site itself when you double click the index file directly. So I will do a compare contrast of the two ideas that I will be discussing. On one hand, I will be discussing with you the content itself. For example, let's go to the forum and here, and on this. So I'll open the terminal, get to the Octopress folder, which I think I might have. Come on, open. And so terminal opens. I will go to Octopress, which is where I ran my exercise the last time. And there I have a bunch of things, including my public folder, which should contain some render HTML, JavaScript already. If I now open the Explorer or whatever this thing is called, and go to the Octopress folder, and then double click the public and index HTML and open it, it should open Firefox. And it kind of sort of looks like a site, but it is not. It is a file representation of the items in the folder. So this is one view that I want to compare. The second view I want to compare is actually a site representation of the same thing, which is represented by bundle exec and then rake preview, where by doing this, I'm actually running a server. And this server is exposing some services on this port number 4000. Now let us open that service in a browser window, and I'll visit localhost and go to port number 4000, where I actually see the same file, index file here. But what you see on the right half versus what you see on the left half are two distinctly different things. On the left side is the site representation of the folder. On the right side is the index file itself. You can see the URL, file://. That's the file representation. This is the site representation. So that's the two distinctly different URL endpoints that you see directly on my local computer. When I refer to the same idea here, and I write that detail in a separate blog post, which is I created after I noticed that I missed clarifying the idea here. And those two ideas, left and right, like I showed you a few seconds ago, are called out right here in form of note number 1 and note number 2. These two notes 1 and 2 are basically the left and right view that you saw here. The left is the note 1, right is the note number 2. Left is the site representation of the folder in this case, or bucket in the case of CloudFront or Amazon. Right side is the folder representation. Left is the site representation, website representation. Let's go read that one carefully. So this endpoint, like this, is the site representation of the bucket, whereas this is the bucket itself, like the folder itself. And those two links are slightly different, very, very subtly. The differences actually belong right here. So this portion is somewhat different as opposed to just S3. That's the difference you will see here. You will see that if I select the bucket, for example, this, and I now copy the whole thing and put it in some kind of a editor and identify what I have. Turns out I have this. Now, if I go to that bucket, actually in Amazon, like that, go to AWS, go to the bucket side in the bucket and identify the bucket itself. Come on. And the bucket was this. So then I go to the properties and look for the static website hosting, which is where I see a website endpoint. Let's go copy that link right here, copy, and then compare with this link. Not really, I did not copy properly apparently. So let's go copy. I should copy the whole thing. Copy and bring it here and paste it. And now you compare the two. What you will notice is the difference is basically this portion versus the S3 portion. Line number 5 is the bucket representation. Line number 8 is the website representation of the same set, same bucket. In example, this is what it looks like: left versus right, site versus bucket, or site versus folder in this case. So what I did not do the other day is the mistake that I did is that here you should actually paste this item. Not line 5, but line 8. That is what is expected. And I conveniently did not, apparently by mistake, I did not clearly call it out that you should use this as opposed to what is suggested by Amazon. Like this. This is wrong. This is right. And when you select that line 8, that it actually changes the origin ID also. You should see that one more time. I'll show you why. So this is another problem that people run into, and that's apparently a buggy behavior in Amazon. I think Alexi and a bunch of others ran into the same thing. So now if I erase this and go back to the top, select the bucket, you see the origin right here. Remember that. And now I will change this name and delete that and put in the one I have in my buffer, which is the site representation. As soon as I paste this and then move away from it, you will see the origin ID should change. That was not changing for Alexi and a couple of others. That's probably a bug in Amazon's console. So now if I go to another tab, you see the origin ID changes. And that was the root of the problem. For some, it was Amazon. For others, it was me, not clearly calling it out. So I'm sorry for that, not clearly communicating that this should be the website representation as opposed to the bucket itself, which is very, very conveniently AWS gives you this choice, which is, I find it bad. But yeah, that it threw me off also, right? In the live video, I just conveniently assumed that that's the right answer, but it is not. This is what you should copy and paste. If you want CloudFront, if you want your content delivery network to mirror, it will mirror whatever you tell it to mirror. If you say mirror my files individually, it will do that individually. If you say mirror my site representation, it will give you the site representation. It will do exactly what you tell it to do. So if you choose this, like the site representation, it will actually show you the site like I see here. That one, it shows up. Whereas if you just say whatever Amazon dropdown gives you, it will individually content delivery network create a wrapper around each object in the bucket, item by item, without paying attention to the site representation, which is what the differences are. Very subtle, but the differences are right here, left and right. Any questions on this, which I think most of you have already overcome this, but I just wanted to clarify, which I think I did. I hope I did. If there are questions, welcome. Okay, and that is also written down in this blog post, which is in the forum, which is accessible to you. And you can also make posts yourself if you like. So go to the forum and go to new topic and write whatever you feel like, or ask a question, or do whatever you want, because this is how you participate. You can, you should. And it's available to you directly on the forum button, like right there. If you click on the forum button here, it should take you to the forum. And that's where you can create a new topic and participate. That's the idea. Okay, let's move on to the next topic, which is where is that? Notepad. No, Notability. So the other thing that, other homework that you did, and almost everybody went through this successfully, no problem, was the idea of, the concept of a signed by, mailed by, and using your own domain, for example, to enable. And I have a bunch of emails. Let me just show you my inbox with success replies. Almost everybody has successfully completed that part of homework also, in which so most of my sent items you will find that I'm saying, yeah, thank you, it worked, yay, and all that. And so let's go pick up one of those. So I think, let's see here, Piotr says, he says, I created my domain, and here is his email. So you can see that the mailed by shows up correctly, signed by shows up correctly, and the domain is correctly configured. Now, having understood these two ideas and having implemented these for you, I would like briefly spend a few minutes to help you understand what does it actually boil down to from a usage practical perspective. Why does it matter? Why is these things, mailed by, signed by, so critical? In one sentence, these things help your company mail, like XYZ, SEMIC XYZ mail, land the inbox. That's the bottom line. These settings actually help your email from your company, like Piotr sends out this email from his email address, from this domain. You want that email to land in the right inbox as opposed to getting discarded, or as opposed to landing in the spam folder. If you want that behavior, which is naturally expected, you want this email generated from this domain to actually land in the recipient inbox. That's what we're talking about, deliverability, inbox deliverability. So you want that, you need to set up SPF, which leads to a mailed by flag, which lets the ISP, like Yahoo, Gmail, Hotmail, and other people, understand that the mail is actually authenticated, coming from a box designated by. So it's a designated by or mailed by. So this is a designation. I designate these boxes to send email on behalf of my company, semic.xyz. That's the designation in SPF record. It is a text record, by the way. There is also another record called SPF type in zone records, but this one is deprecated. So you can ignore that. You will find some references of SPF type record in zone file and DNS. You will find that. That is deprecated. So ignore it. Don't bother. It is a TXT record type. SPF is basically these days a TXT record type. It indicates mailed by. It gives you a designated list of servers, designated servers. Next item is the DKIM signature. It's a digital signature. It is RSA signed, and this is responsible for the signed by flag. This basically means signed by, authenticated by the designated servers. That's what it means. Now, how do you generate? There is a signature. The signature has two components. There is a private component, which the server keeps. The server keeps. The sending designated server keeps. And the public component is what you see in the DKIM entry. Like, for example, dig zoho dot underscore domain key dot semic.xyz. You will find that entry in the TXT record like that. So let's go check that dig terminal, and here it comes, and make it big. Okay, come on, make it big, not print. Quit. Make it big and run it right there. So here is your key. So Piotr has created this key because that's what the public key was. So now if you compare in line number 19 with what we see here, this is the key, which is a text record like that. And it is identified by this signature RSA public key. It begins with a V value, a K value, and a P value. The three values here actually together identify and define the corresponding DKIM record used by Piotr in this domain. And that is why the email sent by his company's domain is showing up as signed by. Now, these two, along with one most important thing that drives this deliverability, is to remember not to spam people. If you do those things, your overall reputation of this domain will improve over time. That's how you build reputation over time. I think that gives you a short summary of email deliverability. It's a never-ending topic. We can go on and on about these days modern machine learning principles and identify how ISPs like Yahoo, Gmail, and others will classify your email as good versus spam. And we can it's a topic in itself. It's a never-ending discussion. I'm still learning as to how to make sure that emails originating from my company don't land in spam, but instead land right in the inbox of the recipient. That requires effort, years of continued effort of not spamming people, of building your reputation, doing all the technological things necessary appropriately and correctly, and keeping an eye on what is happening in your company when people send emails. So you have to monitor that. And that is, I think, enough, unless some of you are interested, in which case we can talk about this one-on-one. But I will move on, because not everybody may be interested in this idea. If there are questions, welcome. Yes, go ahead.
It's John. Where does the validation of that signature happen? Mail receiving process, I guess.
Okay. So the recipient, like me in this case, I am the recipient of the email sent by Piotr. And so my server happens to be Gmail, and they are examining the mail that was sent by this designated box. So let's actually see who the designated box for Piotr is. We can check that out, like right
And
here.
they'll make a callback to, I guess,
Yes, yes, exactly. They'll make a call back, compare with this public signature, and verify, is that true? Is that actually signed by you? Because the signature will come across, and they'll compare with the public key and say, are you the, it's the same idea of what I classified the other day of this file called uh, known host. Where am I typing properly? No, come on. Known hosts. Yeah, this file, if you remember, how it verifies whether the host is known to you, and the corresponding file to this is the authorized keys file, which is on the remote side. That's the way of a handshake and authentication, whether you have the public-private key pair matching or not. That's exactly how even this works. Where my server, or rather my Gmail client, which is what I see, is investigating whether this email is signed by the correct designated server or not. You can find out who the designated server for this is by running another dig query, like this dig, and it will be just this domain, and say txt record. There we go. So we have, this is the SPF designation. Piotr has designated zoho.eu as in European Union, including all the machines that Zoho company manages in European Union as the authorized, or rather designated sender machines for this domain. And there is one little trouble here. This tilde is something to think about. Not necessarily right now, but this is something I want you to know about this tilde. So let's go talk that briefly. This tilde actually has, let's go see this. What does that mean? So this tilde can mean, let's go read. I don't remember. So let's go find out what that means. So what is it called? SPF. No, not SPD, but SPF. So SPF is sun protection factor. No, SPF is this. So at the bottom, you will find that there are references to this tilde and other business. So here it is, qualifiers. These qualifiers, there are 4. These are the plus qualifier, a neutral qualifier, a soft qualifier, and a minus qualifier. My opinion is that the minus qualifier is the best. Best as in strict test. And the tilde qualifier is kind of soft. It's somewhere in between, like, if you're debugging something as to why the email is not reaching and all that, while you are debugging, like it's a new domain. So that's why Zoho will tell you to use the tilde symbol and allow you to actually make sure that everything is okay. And the idea is that once you feel comfortable, you should change this tilde to a dash. And thereby, you're asking the recipient mail machines to drop email if it is not originating from zoho.eu. If it came from some other box somewhere on the planet that is not designated in the SPF list, please drop it. Like completely drop the ball on the mail, and don't even bother reading. Don't even bother putting in the spam folder. Just drop the mail as if it never came. That's what you want. If it originates from some other machine, it basically means somebody's trying to spoof you or pretend to be you. You don't want that. So any email coming from other people, other boxes, just drop it. I don't care. That's how strict you should become after maybe a couple of days of testing, or maybe a couple of weeks of testing, depending on how much you want to test. But that's what you should do, is go strict. Let's go read that one more time before we finish. So a pass is basically ignore whatever it is and just pass. That's a bad thing to do. So don't do it. The plus is a bad idea. Not doing it. Neutral is like I don't know what to do. So I don't have a policy. I don't have a policy to allow or disallow any mail servers designated for my company. So even if somebody else sends, I don't really have a policy. So you may want to take the email or you may want to not take the email. So these are my guidances. So when you say minus, It is a guidance that you're providing to the ISP, Hotmail, Gmail, Yahoo, others, that, if somebody else sends an email on behalf of my company, drop it. That is my guidance. And I publish that guidance on the DNS system. Therefore, minus is the strongest and it should be rejected. That's how it should be done. After a couple of days, you should change it to a minus. It is more strict. That's how you want, because that will give you this clear, comfortable feeling that nobody else, no other machine can send an email. And if they do, it will be dropped. At least you hope it will be dropped. But I think most ISPs these days are honoring these techniques like SPF and DKIM, and those are generally accepted principles. So you can see that it's actually an evolution of collective RFC published in 2014. This is the RFC SPF. You can read that, and it is generally accepted. So people are actually implementing it across the board. Now, having said this, the two records. There is one more record which I think you should think about, and that record, I did not mention the last time when I discussed these briefly, and I think I didn't even bother to, I just named them DKIM, SPF, and I said, okay, we are done, go do your homework. And most of you apparently successfully did. It's actually easy to do. But I did not mention another record, which is also related. It's more like reporting of these records. So there is this DKIM record and the SPF record, and there is one more called DMARC record. And this is like a collective reporting. So it gives the domain administrator a way to look at what is going on, and will give you a report every week or so. So I generate these, rather I receive these reports from a company that I use as a DMARC service. So let's see if I can find out some DMARC records, or rather, yeah. So there is my digest. So you see that there are 5 emails sent out last week. Very, I don't know why it's so low, but yeah, 5 emails sent out. 100% were SPF and DKIM aligned. And the emails were sent by this company, which is my designated company. And that's a report. Now, this report was generated by this company for me, Postmark, which is our mail sending company, which is what my machine uses to send mails for my company. So when automated emails go out, for example, you lost a password, so you want to get that password restored. So you need to say, hey, send me a password, forgot my password email link. I can go back and reset my password. Those emails, I don't write them by hand. My machines write them. And those machine emails also need to land the inbox. If they don't, then you will not be able to reset the password. And you will complain and you will say the site sucks and all that. You hate the idea that I cannot reset my password. That's a bad thing. And it is a critical thing to happen to actually have that password reset email land your inbox. And if it doesn't arrive right away, you get frustrated. It's natural, right? Expected of people to, I say, click my password reset button. I need to receive an email so I can reset my password. And that doesn't happen. That's a problem. It's a big problem for business. Huge. Which is what these tools help you avoid. So now, if you look at this DMARC service, by the way, there is a company called DMARCian, which I would suggest that you use. And you can start a trial. I think they used to be like perpetually free, but these days they are charging. I just want you to know that this is not a free service anymore. But this site lets you keep track of aggregate as to what is happening with your domain with some reports. Like I just showed you in my inbox, I just showed you the DMARCian reports. Where are those? Here. Yes, I showed you this another one. So 3 emails processed on this company domain, 100% aligned, 0% not aligned, which is exactly how I want. And the emails are being sent out by Amazon Simple Email Service. Now, these reports happen because of the tool that I have used here. And that tool is, I think, well, let me go find out that tool link so you can also put it to use. Postmark, DMARC is this website, which actually collects that system and keeps track of all the emails flying around on the global internet with your domain name in picture, and will check for SPIF, check for SPF, DKIM records, and collect a report every week and send you, the domain administrator, how is the health of the system. That's what you want to know. And you can take corrective actions on A versus B or things of that nature. So this service apparently is free. So I will paste you a link right here. Apparently, is that the right link? Yeah. So here is go. That way you can configure. You have to basically give your name and email address. It will generate a new DMARC record. And let's see if I have a DMARC record to demonstrate for you.
You showed us two different companies. That last one is free.
Yeah. The second one is the one I pasted a link for is free. This one, the Postmark, that one is free. The DMARC part is free. And here is my DMARC record. You can actually read the DMARC record. I will read it for you. This is how it looks like. I'll dig query again. So the query is dig and underscore DMARC dot is the record you want to create, underscore DMARC, like that, and the domain. And it's a text record again. So I go read, I find the record like that here. I'll take the record to a notepad and review. So now we have it. It is a DMARC record under the domain, which is basically a TXT record with a bunch of flags, lots of flags here. So DMARC, the reject policy, if the SPF is broken, reject, the DKIM, there is specific meaning to these symbols. So that is what we have to go read the specification as to what the meaning is. And I have no idea what the meaning is. So I will have to also read because there's so many of these. But in line number 9, sorry, not 9, in line number 10 and 11 is where you will find that line 10 and 11 are the locations which will receive DMARC reports. Now, who sends DMARC reports? DMARC reports are XML files sent by Hotmail, Gmail, Yahoo, this and that, all the ISPs. They send out reports, DMARC reports, because they know what is going on the planet. Like that's where the most of the emails is sitting, unless it is corporate email, in which case they have no idea, but corporations do. So email sent to Boeing will probably not be in such reports, but email sent to Yahoo, Gmail, Hotmail, and others on the planet have a systematic method of sending out reports in XML format to a recipient designated in line number 10 and 11. Now, I don't want to personally receive those reports because they are like kludgy XML reports, which are not human readable. They're not really. I mean, you can read them, but it's kind of clumsy. Who wants to read XML reports sent by Hotmail on behalf of what again? I don't want to do that. No, it's too much. So I use this service. And I say, you know what? You receive my emails in XML and you summarize them and you give me a nice report every week. And that service is what I'm using right there. This one, this service. So they aggregate these reports coming from a variety of ISPs, and I get an email every week. This service is free, and I like it and I use it. You may want to use it for your domain, unless, actually it's not that critical, by the way. It is only when you really get down to running a business, a company on your domain, then you have to worry about these things. But I'm telling you that you need to. Most of you have personal domains and you have personal interests, so you should just enjoy. Unless you want to convert that domain into a business for real, for serious, then these things apply. For personal usage, you send an email to your friends and family, no, don't bother. Not important. But technically, yes, do it. So that's what I would suggest. I think that's enough of email discussion. We can move on, unless you have questions. So we did this. Okay. So questions are welcome. And I'm switching topics right now. So what I want to do now is go find out where I was in this location. Oh, I don't even have the site open. Okay, let me go open it. And what I want to do is discuss what network capabilities do we actually see in the context of cloud companies, for example. So we'll like to build what I would call a private cloud. It is not going to be something like your Boeing company has inside, but it is what you have is OpenStack. Like this is a real private cloud in your company. You have it, it runs, it looks like this. That's what you probably deployed. The entire set of machines and software and all that, it is running in your company, which is your private cloud. It is local to you, local as in your building. What I'm talking about is also a private cloud, but it is not going to be local to our building or your building right now. I'll be using this AWS as an example. By the way, the same exercise you can do in any big cloud company like Amazon, Google, and Microsoft. Same thing. You can do this thing anywhere. The same exercise. I think Vukash has already done this. So that's nice. He already finished through the steps. And so he has, I think, some questions about it. So I will answer those questions as we go through it. Now, if you go back to Amazon's console, and you will find that there is this section in network and content delivery here, which is where this thing called VPC shows up. And what this is basically a private cloud, basically what you have here in your company. But we will be creating the same structure in this cloud. And we'll use this button, VPC button, to go to that location and configure. And you will notice that in my screen, I am in Oregon. So just remember your region where you are. Don't forget that part. That is one of the most critical things in Amazon, is to remember where you are currently. You can select and go to any other cloud, but I am currently in Oregon, US West 2. And with that understood, let's go look at this screen. It says I have one VPC, one. That was given to me by default, like everybody gets one. It is also known as the default VPC. And there is something that I want you to know, and this is very specific to Amazon. The thing that I want you to know is do not delete the default VPC. That's what I want you to really, really remember. Don't delete it. You can delete it, no problem. But it will cause you trouble in the second segment. In the DevOps segment, you will run into some trouble. I want you to avoid that. To overcome the trouble, you have to actually call Amazon AWS and open a support ticket and all that. You don't want to do that. So just simply what you have here, the default VPC, just leave it alone. Don't touch it. Don't mess with it. Don't delete it, because there is no way to create another. There is a way to create a VPC. You can create a VPC, no problem, but you cannot create a default VPC. That's what I'm talking about. You cannot create you can create a VPC, but you cannot mark it default. That's a design problem in Amazon. So remember, don't delete what you have. This one, the one I have, just it is called default, and you can see that the default VPC says yes. You can see that right here. Default VPC says yes. So please leave it alone. So I'm going to actually label it like here. Leave it alone like that. So just don't bother touching it, because I don't want to mess with it, because I need it in the second segment, in the DevOps segment. Having understood that part, let's go back to Amazon and go back to the VPC dashboard, like right there. Now here, there is a wizard, and you can click and get a VPC done in like 10 seconds, maybe 30 seconds. And you have a new VPC. And that's nice. But that's not what I want to do, because this is like, This is done for me. I don't want it like that. What if I want something else? I want to understand. I want to go deeper. I want to really build item by item. So I really know what am I building so that I can design the infrastructure I need for my applications in exactly the way I want, as opposed to using the cookie cutter approach. These are 4 cookie cutter approaches. 1, 2, 3, and 4. I don't want any of them. So what will I do? Go by Scratch. But before I jump into the detailed Scratch exercise, I want to understand what these cookie cutters are quickly, not spend too much time. So let us understand what these things are, beginning with this one, like VPC with a single public subnet. You look at this picture. That's what it's going to do for us. There is internet, and there is S3, and there is DynamoDB, and there's other services, and there is CNN, and there is Yahoo, and all that. And all the other companies that provide us a bunch of services on the internet that you probably already know. Like, like this internet, where is the draw pen? Okay, where is the internet here? No, it's not drawing. Hold on. So there is this internet, and then there is other people like Yahoo, CNN, Fox News, like that. All these services that I occasionally visit. So you can read. These are things on the internet, like stuff on the internet, like cats and dogs, like that. So that's the internet part together. But inside this segment is what I will classify as the private cloud. And it is virtual, meaning it is not real. I cannot go and touch it. It is also away from me, not in my office. So it is in Amazon. So it's Amazon Virtual Private Cloud. It is pretty much like this. Sorry, I don't like this annotation, so I'll just clear and discard it. Clear and say go done with, yeah. So this is what your private cloud in your company is. This is going to be my private cloud in Amazon, and it's going to be virtual, and it's going to be away from me, so not local. And let us see what does this actually mean? Where have you seen this kind of a setup in another location, not in your company like this, not in Amazon, but each and every one of you has a setup like this. Do you know where it is? This kind of setup, anybody? Pretty much like this. There is a boundary here around your private area. Like this is your
home router.
Yes, exactly. Your home is like a VPC. Exactly, sir. That is beautiful. So that's what I'm talking about is, when you construct a VPC, you basically create a home away from home. Home away from home. You have some location where you basically have a home which is away from your actual home. And this is where you live, and this is where your computers live. That is your home, away from home. And so you want to protect your machines sitting here from bad people outside. If there are bad guys, you want to protect your machines from the bad people. You want to protect your laptop here and your iPad here from bad people who are outside trying to attack. And they exist, by the way. Bad people exist. And they are there in your neighborhood, and they are there on the internet. They just exist. You want to protect your home away from home from bad people. And at the same time, you want to allow good people to come in. Not personally walk in, but visit or access services that you run here. You want to run services there, and you want people to visit them through a browser, not personally walk in, but visit through a browser, access the services on some protocol, on some port, and you want to allow that. At the same time, you want to keep the bad guys out. So you want to have a front door, and you let people in, they can walk in. and sometimes you have a back door, all that. But you control the gates, you control the doors in your real home. So this is your real home. This is your VPC. Pretty similar. What do you do from a from a home setup? Like this is your real home, for example, and you have your laptop. Do you take a modem from Comcast and connect your laptop directly? Sorry, I should draw it this way. You have a real home. Do you do like this? Sometimes do you do?
Nilesh,
Yes.
you're confusing. Nilesh, this is Rob. You're confusing me a little bit because the modem that I have from my service provider is also a wireless and a hardwired router.
So the modem, you should not call it a modem. You should call it a device that contains a modem and a router. It's a combo device.
Okay, so what you're saying, because I do have the option on my device, it is a modem, it is a router, and I do have the option to connect directly to that device, and I sometimes use that because of certain circumstances. But then I also have my own personal router connected to that.
Right.
Then I use.
So I'll tell you the reason why you want to connect your laptop directly to the modem, but most people, not everybody, most people don't do it this way.
Yeah, okay.
Most. Some people do. There is a valid reason for that. Most people don't do it this way because it's not really a good idea to connect it like that. And I'll tell you why it's not and when it is good and when it's okay. So the device you seem to have is a combination device. I will not call it just a modem, although Comcast would love to call it a modem because they want to confuse everybody. And they do some other things that I will discuss briefly. But we are not discussing Comcast. We are discussing concepts. So this is a combo device. Let's think of it as a separate device. So let's call it the modem part and the router part, the two different devices here in question. What does the modem do? It converts a coaxial cable into Ethernet. Let's think of it that way. That's what modem does. What does a router do? Let's understand that piece. A router has multiple services. One of them could be network address translation service. The other could be DHCP service. There may be other services that depends on the router company. My focus today is on this service capability in the router, not this, not this. That's what I want to talk about, is the NAT capability of the router. And I'll tell you what NAT is. DHCP is, and I'll discuss briefly what DHCP also is, but modem basically takes a round coaxial cable and converts into an Ethernet cable that looks like this, that you may have in your homes, or you may have it at the back of the modem. Ethernet cable. The router takes one and gives you many Ethernet outputs. These are typically inside.
Okay. That's what I wanted to understand is when you said modem, I wanted to understand what you were talking about versus what maybe most of us have is we have a combined system.
Correct.
And
you have the whole thing together is what you have.
And I wanted to know if you were just calling that whole thing the modem or if you were really talking about just that single point.
Yeah, so let's go search what a modem is. And modem is basically something like this. Here it converts one protocol to another, like a phone system to dial-up modem converts into internet, right? That's the connectivity thing. You can have a look at other modems, like this one, for example. This is a DOCSIS capable cable modem, which is looking like this device, and it converts what? It converts the cable connection into an Ethernet connection. That's all it does. There is no other thing. This, to me, is a modem. That's what it does. Converts the cable signal into Ethernet signal. And that's end of it. End of story. There is no other feature. It looks like this. And it gives you these items. Cable goes in, Ethernet comes out. Nothing else. That's a modem. Everything else is something else. Now, what is a router? A router is multiple capabilities. Like I discussed, a router may look like this. It may look like something else. But if you watch carefully on the back of the router, let's see if we can find a decent back picture of the router like this one, somewhat half decent. If you look at the router, this to me is a router. It gives you 5 such connection places, holes. 1, 2, 3, 4 blue colored, and the 5th one is internet. That is what I call a router. It has 1 connected to the internet and 5 connected internal to the home. There is also this antenna. We'll talk about the antenna also, which is also a part of, let me shut this machine down. I think I don't need it right now. So I'm going to shut it down quickly. It will improve the video conference performance a little bit, shutting it down. Okay, now where is the display? So this wireless thing, right? We'll discuss the modem. Was very, very simple. It takes cable connection and gives you Ethernet output. That's my definition of modem, Ethernet. And my definition of a router is it gives, or rather receives internet in Ethernet port and gives you 1, 2, 3, 4 Ethernet ports, internal use. It also gives you more than 1 wireless internal use Wi-Fi access locations. It is very similar to these, but these are wired, these are wireless. You can have more than 4, or probably depends on the capability of the router. This to me is a router. The function here is convert internet address space into private internal address space defined by this RFC. That is what I'm specifically talking about, is this RFC. So let us see what that RFC does. It is called RFC 1918, address allocation for private address spaces. You can read this RFC, but when you were like at bedtime, it's a good bedtime reading, so I'll skip it. Go back here and read this article instead, Wikipedia, much simpler, and focus right here. And here you see that the RFC 1918 provides 3 different blocks of addresses, which are collectively known as private address space. That's what I'm focusing on, right? The private side versus the public side. Now let's go look at the address ranges again. The range is 10.000, 10.255.255.255. The whole range, except you notice this number 10 doesn't change. Similarly here, 172.16.00 all the way through 172.31.255.255, and like this 192.168.00. This is very commonly used in homes, all the way through 192.168.255.255. So now, having understood this piece, let's go look at our picture one more time and write them down. So 10 dot something dot something dot something, and in these boxes you can fit any number as long as it is in between these values. You can put 0, 1, 2, 3, like that. Any number that fits in the entire space from here to here. So there are basically 256 numbers you can put in this box, 256 in this box, and 256 in this box. That's a lot of numbers. Lots of address space, right? How much? You can tell. 16 million addresses. That's what this number is, 256 times 256 times 256. There are 16 million addresses available for private address space in this range. Now, it's very hard and difficult to communicate the address space in this highlighted example. It's very difficult to say this by mouth on a phone to somebody. Like I'm talking to somebody on the phone and I'm going to communicate to them. I'm talking about the address called 10.0.0.0 all the way through 10.25.25.25. The other guy on the phone will say, what? That's the problem. So there is a shorter way to communicate this same thing, this same blue highlighted address space. The shorthand notation for the same thing is here. That's how you write it. And I'll tell you what it means. So the shorthand notation of the same thing is called CIDR, classless internet domain routing. The shorthand notation goes like this. That's what I will say 10.0.0/8. That will succinctly communicate what I have in mind as the address space allocated to private areas under this RFC in a 24-bit block. I can just easily say on the phone, hey, 10.0.0/8. People understand because they know these things. Like, at least once you get familiar with this idea. If you're new to this concept of CIDR, please read what CIDR is. And here is a link. So read it, and I'll explain that briefly with some examples so that you will get to what I'm talking about, CIDR. That's the notation that you will find very, very commonly available on, the internet. People will use this notation generally, but they are basically defining a range of addresses. Each one of these guys, there are 4 of these guys. They are called, basically byte. If you have a byte which can contain 8 bits, like that, I just made 8 dots, if you can count them, or rather I should say 1, 2, 3, 4, 5, 6, 7, 8. There are 8 bits of information stored in this box. 8 bits in this box, 8 bits in this box, and 8 bits in this box. So in total, there are 32 bits. So in 32 bits of zeros and ones, I'm trying to communicate my address space. If you want to read more about binary numbers, you are welcome to read and discuss with me later on. I'm not going to binary math right now. I don't want to, unless you want us to. And if there are 4 people saying, yes, tell us about binary math, I will do it. But I need to have 4 people asking me specifically right now. I will skip this unless you tell me to stop binary math. Okay, so this 10.0.0/8 is the way to describe this entire range all the way through this range. And what I'm really communicating is the same idea with a shorter representation. Now, if you write the same thing and change this 8 to number 12 or number 16, what it boils down to is the number of bits from this side towards that direction that you are masking out. That's what it basically boils down to. So if you have 16, it will look something like this. And again, we are not doing bit math right now. We can, but don't want to. And so here, this address space, 192.168.0.0, all the way through 255 to 55. Only the last 2 bytes are variable. So if you now look at that example, 192.168, this has to be the exact same number. Don't change this. You cannot change it. It is a standard. It is frozen. It is stuck. That's the address space. Here you can put whatever you want. You can put 0, 1, 2, 255, anything in between. Okay. And same thing here. That's okay. So you have about 256 addresses here and 256 addresses here. The possibility multiplies to 65536. 64,000 addresses, roughly speaking. This is 64K. 64K as in K is 1024. So 65,000 addresses, 65536 to be precise. That's what you're looking at in this number. The number of addresses. These are available in a private area network. So these are addresses specified as standards. Now go back to our picture again. The router, what it is doing is creating an address space for us, internal use address space, which fits the RFC. And there inside, you can create, in most homes, you have this address space. So if you check the IP address of your local machine in your home, you will find an address just like that, unless you don't, in which case you will find an address like this, something like this. Unless you don't, in which case you will find an address something like the third one here. And that's the idea of creating a private address space. Every home will have something like this internal to that area. Every VPC will also have something like that. Let's go see what this default VPC that we have apparently here actually does. So I'll go to the VPC that I have. It's the default VPC. I'll quickly examine what it has, and I see that leave it alone, but I will go see its subnets. And in the subnet, we have the address space CIDR block showing up right there, 172.31.00/20, and like that. So these are addresses called out as a subset of the bigger private segment. This is 31, by the way, 172.31. What was this? It is also 31. So it is a part of the same private subnet, is being chosen as a portion of the bigger 20-bit block as this VPC subnet. So that's brief intro to subnets if you are not familiar with it. If at any time you feel that this is too trivially simple information, please stop me, or rather ask me to go forward. If you find this is boring, ask me to rush. If you find it is too trivial, ask me to rush. If you find that it is too difficult to understand, ask me to slow down. I really have no way to tell whether you are understanding it or not, but I want to make sure that you do, because these are nuts and bolts building blocks. If you don't get these parts, you will have difficult time going ahead.
It's Alexei. I don't know about others, but I still have difficult math understanding the CDIR notation.
Okay, what I would like to know is, please tell me if I speed up or slow down, because that will help me appropriately adjust the delivery that I'm doing. I might speed up if you want me to. I will slow down if you want to. I'll go deeper, go shallow. You tell me, please guide me. If you don't guide me, I will have no idea. And I don't want to lose you. I don't want to bore you. That's my goal. I want to keep it interesting, keep it really practical in terms of usage, and not bore you too much with nutty details like binary math. I'm not doing that, so I skipped, unless you want me to cover. So you tell me.
So Nilesh, this is Rob. So one of the things that's really cool about this, and what I'd like to see, is I've already learned some things about the private network that you just taught me, but how, just like in our home, we have our router or modem has the internet IP address. Where do we see that here in our VPC and connect, and then make those two connection points? Because right now we have one person that asked for the CIDR notation, maybe do a little bit of math there, but then how do we connect to our VPC from the internet, from the outside world?
Yeah, yep, we'll get there. But a short answer is right here. But we'll get there. The answer is this, what you see on the screen. And that's how you get in. That's how machines go out and like that. But I'll give specific examples. Let's keep going. So I understand. What I would like to now do is close, and continue. Okay. So the address space internal is kind of limited by the RFC that I mentioned. The address space outside is everything else other than this. Let's go see what that means. So the address space on the outside of the router, and this is the inside part. The inside versus outside. Inside are the private ranges. Outside is everything else. But what is everything else? So on the internet, if you're using the IP version 4 protocol, the address is typically assigned in these 4 boxes. There is some address number like blah, dot, blah, dot, blah, dot, blah. That's how addresses are. And as you know, these are, 32-bit wide. So each one of them is 8-bit, 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 which means they can fit anywhere between 0 through 255, 0 through 255, like that. And so what does that mean is that each one of these, it can contain 256 values. What does that mean? That the total number of addresses available on the internet is this number, which is about 4 billion, roughly speaking. So that's the entirety of the internet, 4 billion addresses, IP version 4 protocol. Now exclude this. Now draw a picture like this. This is the entirety of 4 billion addresses. You carve out the 1918 RFC addresses, RFC addresses, and that is designated as private. Everything else is outside internet. So if you now look at what is my IP, what do you see here is the IP address, not of my laptop. It's still loading. It is not the IP address of my laptop, but it is the IP address assigned to my home by the Comcastic company. This company has decided that they will allocate this IP address to my home. It is not the address of any of my boxes in the home. I have 13 or 14 of them, including the machines in the garage, but none of them have this address. So where is this address? Let's go look at that picture again. What the Comcastic company, the ISP that it does is gives you one IP address. That is the address you just saw on the website here, this address. That is my public IP address. And that is assigned to the router by the modem. Here is cable connection. Or maybe in other countries, like in Singapore, we have optical connection. That's a far more advanced country than US. So they have optical cable. Some of us do actually in the US also, but I don't have it. So optical connection, cable connection, that is what the modem will receive. The modem will then generate a public IP. And that is what you see here is the outside public IP. Is the address assigned to the okay, where is the picture, that one. And to the yellow item here, this internet label box, the yellow colored Ethernet port, that's where you will see this address on the router. Not the modem. The router will receive this IP address assigned by Comcast. That's what you see right now. That is exactly very, very similar to C that you will find in a VPC, where the gateway company, the internet gateways company, will assign an address or a connectivity like this into the VPC. So I'm saying leave it alone, I'm not touching it, but that's where you will find internet connectivity coming into the VPC, because that's what you allocate, and you attach the gateway to the VPC. You can detach it, and that will like break the cable. That when you detach, it is practically taking a cable and saying, detach this wire. When you do that, that's what you do, like this, detach. So now the connection between the internet or the world outside has been disconnected from the VPC. So I can attach it back to the VPC if I like. I'll please attach to the leave it alone VPC and say, yes, attach. So that's the cable connection I just did. I'm changing this red colored cable, plugging it out from the yellow port. That's what I'm really doing in the router. In actual example, like I just showed you, by doing it on the cloud, doing it straight in your home. So now let's go further inside here. Just change the color of the ink again here. So inside here, these are 4 IP addresses you get from on the machines that you have. Say laptop number 1 laptop number 2, desktop number 36 that you might have. You will connect these things directly. Sometimes you connect laptop number 32 with a Wi-Fi connection. But each of these items will receive an IP address in the private RFC 1918 portion. And this IP address is generated by the router. You can see this detail in my example right here. You can see that this address here, 10.0.1.14, was assigned by the router to me on this machine. And my router is this box. It happens to be an Apple Airport, but that is what is assigning me an IP address space of 10.0.1 dot whatever. So I can get addresses as long as they belong in this last byte. I have frozen everything else. This is frozen by the RFC. I froze these and these, and then I get machines here. So each of these machines I have connected to the router airport will get allocated an address like that. That's what you see in the IF config. You will see that the address allocated is 10.0.1.14. And I have a bunch of other things connected to the same machine. So that's why you have too long of a list of IP addresses. So I filtered it. But this is the primary adapter. And that's the IP address that was allocated by the router. And it is a private address, as you can see by the RFC notation, 10xxx. Okay, breaking it, going back to our design and continue our discussion, is what we are really trying to accomplish is carve out a subnet in this overall range. And I'm freezing this portion. This one is frozen by the RFC, so I don't have control over it, but I froze these guys and said, this is what I want. So any machine in my home belongs in this address space. So I can, in shorthand, say the same thing like this: 10.0.1.0 slash, and what should I say here? That's the question for you. So I'm just trying to see if you're paying a little bit of attention or maybe thinking ahead as to what I might be asking, but I'll illustrate some examples before I actually ask it. Let me give you some examples. So I said 10.whatever.whatever.whatever is expressed as 10.0.0.0/8. That's how you express this idea. Now, if you want to express the idea of 10.32.whatever.whatever, and I'm freezing this myself, I will express this in CIDR notation like this. So what should be the number here? In my example, in my home network. In this, what should 24. I write?
24.
Yes, you're right, sir. Absolutely. 24. Why? Because if you count the bits from this direction all the way up to this point, it's 24.
So it has to do with the net mask, right?
Exactly.
So 255, 255, 255, it's 8, 8.
Bingo, 8, 8, and 8. Okay. Add them up, 24. That's how you calculate the bit mask. Clarifying this one more time, in my home location, I have 10.0.1.14 address as the laptop that I'm using right now, which means this number is actually a variable. So other machines will have similar addresses, but this will be different. So these are 8 bits. These are 8 bits, and these are 8 bits. So I'm putting a net mask, masking out these because they are frozen. This was frozen by the RFC. This was frozen by Nilesh. And so they're frozen. I cannot change the number 10.0.1. All I can do is change this last digit. So I said mask it by 24 bits, starting like this. So 8 plus 8 plus 8, 24. That's what it goes here. And this easiest way to think about these ideas without going into too much complexity, which will become complex if I go to any other number other than 8, 16, or 24. If I just make it 7 or 9, it becomes clumsy binary math. And we can do that, but I don't want to. If you want binary discussion, let's have it separately. If you think about these numbers, how many addresses are in these? So if you answer this question for me, how many addresses can you tell? How many here? It's easy. You probably saw this right here, right? Only the last one is changing. So think of it as divide by 24, not really, but just a thumb rule. So if you divide by a bigger number, the number here will be small. So the quick answer is 256 addresses. You can only change this last portion. It can contain any number between this range. So 256. What about here?
64,000.
64K. And here will be 16 million.
Okay.
Right? So if you extend this idea in that direction, so it will be 10, 0, 0, 0 slash. Actually, it will not be 10 because now this will also change. So it will be 0, 0, 0, 0 slash, and then 0. That the answer to the how many question will be 4 billion. Because it is 256 times 256 times 256 times 256. All of them can change. Nothing masked. And this is the entire internet. Now that's this direction we chose to go. So 8 became 0. Now if you go this direction, the logical answer is 10, 0, 0, 0 slash. Logically, it will be 32. So how many addresses?
1.
1, exactly. So this number that you see here, this address, the address you see here, I can show this address in CIDR notation, which you will probably laugh if I show it to you, but you can write the same thing like this. You get the point? You write an IP address or the entire range of addresses available to my home as line number 7. Only one address. That's how you write in CIDR block. You can write it like this for simplicity, but to be precise in the discipline of writing CIDR, this is how you write, /32. And when you represent the entire internet, you write like this, line number 9. It represents the entire internet. Line number 7 represents my home. That's the concept. And anything in between are these examples that we were handwritten, like these examples, like this and this and this. So if you go like 7 and 6 and 5 and 4, in case of 8, that will lead us to discussing binary math. So I'm avoiding it. We can. Okay, let's move. Having discussed that, let's go close this window, and go back to here. What I want to now do is go back to that the picture that we had in terms of the VPC giving us a wizard. That wizard gave us these 4 choices. We had the internet and this little box. This little box, as you can see, contains one public subnet and Amazon Virtual Private Cloud. And you can create boxes like these little squares indicate that there are boxes inside the public subnet. Now, implementing this is like a silly design. It's okay. There's nothing wrong with the idea as such, but that's not how most large-scale corporate enterprise applications run. You would rather have none of your critical applications run directly on a public subnet. None of them. This public subnet is basically something that you will see when you go to the Amazon's console, go to EC2 section, and start a new machine that we have done in the past. You will see that if I start a new machine like this, and then I go next, and then I go next, and then I go next, and all that, if I go through, machine will get me a public IP address, as you recall, right? The machine will allow us to connect to that machine pretty much like this. Pretty much like this, you can connect to that machine that you will create from Amazon, and this is the public IP of the machine that we would start. What I just told you is not how enterprise applications should be deployed, meaning they should not be directly on a public IP address. Like in the example here, it gives us, if you just go default choice and select and ask Amazon to create a machine, they will gladly give you a public IP, but that's not what you really want. In fact, you want to tell Amazon, please don't give me a public IP. I don't want it. I want to keep my things secure, so hide it away from the public and don't give me a public IP. And when you don't have a public IP, then how do you connect to it? I mean, that's another question, right? So we'll discuss those aspects, and we'll do an exercise on this idea. So when we don't get a public IP, how do you connect? That's something that I want you to understand, and we'll have to create some setup to enable us to do that. But bottom line, when you have critical applications, you don't want to be running them on the internet connected machines. That's the bottom line, which means you have a machine here and another machine here and another machine here, like that, bunch of them. You don't connect to the internet. So what do? You still want the machine to connect to CNN or Yahoo or God knows whatever you want, or maybe Ubuntu.com or some other machine. You want the machines to be able to go out, but you don't want them to be connected to the internet. That's what I'm talking about. That is simply the same idea when I said that, you know what, when you have a modem and you might have a router, but you have a laptop and you don't connect the laptop directly to the modem because this laptop will get a public IP. And that is not what you want. And therefore, most of us don't connect it like that.
It's Alexi, question. So if all the machines are connected, for example, like my home router, so if I request a website, how does my router know which machine to send the request? Because they all use the same IP address.
Correct. So the scenario that you have in your home is like this.
Yeah, I have multiple.
Yeah. So you have multiple, and let's go, short list of 2. You might have more. So the router will assign a private IP. Router itself has a public IP assigned to you by the service provider. Okay. Now, this router is a liar. Is that the right spelling of lying? I don't know. Yes, probably. It actually does. Technical term for this lying is called masquerade. That's what a router does. What does that mean? So this is the technical implementation of masquerading. You can read that link if you want, but I'll tell you simply what it does. It is basically saying that when this laptop, you sit here, like this is you sitting on the laptop, open up a browser, and you say, I want to go to CNN. So you send the request out.
I don't go to CNN.
Sorry?
I don't go to CNN.
Fine. Let's go to Fox News. Yeah, let's go to Fox News. And you don't want fake news, right? So you want real news, you go to Fox News, and you want to say, okay, go to Fox News. And so it shows you, your laptop will send a request for this IP address by doing first thing, dig fox.com or the Fox, is that what it is? Dig Fox. I don't even watch these news websites, so I have no idea what CNN is or Fox is. I just use these names for no reason. But first thing, dig fox.com. So that's the IP address that you want to go. So let's go visit fox.com. So fox.com. Is it fox.com? Yes. So we're visiting fox.com and it's opening up, and what my router just did is requested a DNS query for the name to number translation. So got this IP address, and then router will basically forward that traffic and pretend to Fox that, you know, it will send that request out to Fox and say, hey, Fox News, I would like to see what you have. So please give it to me. And by the way, I am not the router. I am laptop number 1.
So it's just a big proxy?
It's a masquerade. It's not a proxy, it's masquerading. It's lying to Fox that I am laptop number 1, but it is not.
Okay.
That is masquerading. Now, at the same time, your friend visiting you might be visiting google.com. And so this laptop number 2 is opening up a different browser, and it says Google. So it will do the DIC query, go to the IP address, and the router will actually go to Google. And this time, router will be lying again. It says, hey, I am laptop number 2. Would you please give me what you got? And so the Google server thinks, oh, you're laptop number 2. Let me give it to you. So it gives you Gmail, whatever services you want to use from Google, and Fox will give you the news that you want to read. When the router receives that request back, it says, oh, it was meant for L2, so let me send the Google traffic to L2 and the Fox traffic to laptop 1.
So so the router pretty much tracks all the connections and separates the connections in between and
Yes,
okay.
yes. That's the idea of router. That's the idea of masquerade. That's the idea of what I simply called lying. It is actually lying. It says, I'm laptop number 1. You're not. You're the router. That's how he lies. And that's lying, I think, is not the technical term, but you read this, masquerade. And so I'll paste a link for you. That's what masquerading is, and that's IP masquerading. There is a protocol in IP tables. You can read more. We'll implement this a little bit in one example coming up. And next. So that's what a router does. Basically, it's lying that I am pretending to be somebody else, but it is not. And it interfaces with Google services, Fox services, and gets the services done, responds, interacts, handles cookies. Actually, the browser handles cookies, but the traffic is transparently masqueraded. That's how the router functions from a transport perspective. Next, what we want to do is, in the case of our VPC, is we would like to have these machines that we will have internal don't get a public IP. So no public IP, which means we need some IP. It will be a private IP. And those machines will receive a private IP addresses, but then there will be no way for these machines, poor guys, to connect to Ubuntu servers for updates.
I think people are asking for a break, Luis.
Sorry?
People are asking for a break.
Did not get that.
People are asking for a break.
Break. Okay. Good point. Thank you. So break request, and we'll take the break. We'll start the break right now. Thank you. That's the thing that I tend to forget. I have this habit. I have no sense of time when it comes to when I start talking, I forget. So let's start the timer. There we go. Started. Oh, what? What did it just do? No, 7 minutes, not 7 hours. What was it trying to do? 1 hour, 244 minutes? Okay, come on, leave the page. Yes, now it's a good timer. And let us resume after that time.
Malicious John, I gotta take off early today at 6:40.
No worries, no worries. You can just
Sorry
drop
about
off
sorry,
and do your thing.
sorry about that.
Yeah, no worries. Let me also walk away from the computer a bit, and I'll be back in just 2 minutes. Thank you. I am walking away. There's nobody here. I'll be back. हाँ मैं देख के आ रहा हूँ Okay, guys, I'm back. Let's check if people are back.
Some of us are.
Okay, so I think you can hear me and my screen is not sharing. So I'll share it. And let's quick feedback. Is this going the right way? Too much, too little, depth, breadth? I just want to get some feedback. So tell me.
Just about right.
Just right. Good. So if you want to go deeper, tell me to go that direction. I will go. If you want me to speed up, if I'm boring you, tell me to do that. I will go speed up. There is just too much content available for us to cover. And cloud is huge and we have only 8 weeks. That's the challenge. But let's see. We'll fine tune to the speed that you expect and move accordingly. There's a chat question. So let me answer that question. So I think Jerome is running into PuTTY 32-bit and the cloud machine will be 64-bit. Just answering those questions for Jerome, who has trouble accessing virtual machine on his laptop. Okay, I think I did that. Let's go move forward. Here, what I was talking about is that just like in your home, you protect and you don't connect your laptop directly to the modem. You don't. And you know what I mean by modem and what I mean by router. They're two distinctly different functions, two different devices that some companies club together. Fine. You don't connect your laptop directly because you get a public IP and you don't want it. Because just like the machine has a public IP, people on the internet can visit and you don't want that to happen. So you want to protect your machines internal to the private cloud that you want, keep them a private address so that a bad person somewhere on the internet, like here is the bad guy, he or she should not even be able to route to this. It is not routable, not because it doesn't fit the RFC for rather it fits the pub. Let me say it again. It is not routable because it is a private address space, does not belong to the public address space. So there is no route to go there. That means the bad guy cannot even reach these machines inside. That's what you want. At the same time, you want your machines to connect to good services like Ubuntu update service, for example, Ubuntu update. You want to update your boxes or Red Hat updates or whatever other operating system updates, new applications, new things, Docker containers, whatever you want the machines to be able to grab and download. You want the machines to be able to send outbound traffic and send emails, automated emails, for example, like I mentioned briefly. Password, forgot my password, link email. Those machines need to send those things out. So they need to be able to transport traffic in and out, but then they are private address space. So they're not directly routable by other people, cannot get there, no route. So you need something in AVPC. What do you really need is this guy. That's what you need. You need something like this device, but you cannot get a router in the cloud. Can you buy a router from Best Buy or some other store and put this in my VPC? You cannot do that. So you have to do something special about it, something different. Basically, you have to build your own router, or you use an existing router. That's what you have to boil down to. So you go to your VPC and say, do I have a router? Or maybe search somewhere in Amazon and do I have a router? They will not give you an answer. Say router, nothing found. Route 53, yes. Router, not found. You try to search NAT, not found. That's not what they call it, but they give you a service, by the way. They give you a service called NAT. It's not called NAT, but they have a service, and I'll show you where it is. Every cloud company actually gives you a method to create your own router, and creating your own router basically boils down to, let me just see if I can identify that. And this is the code you need to run to convert any Ubuntu box into a router. I'll paste that code for you, and we'll actually do these exercises hands-on, so don't worry about it. There's more chat questions. Okay, so what I was talking about is the converting a box into a router happens like these lines. Will convert a Ubuntu machine into a router machine. That's all it takes. If you read carefully, what it does is sets an IP table rule, line number 3, and sets a masquerade behavior. This masquerade behavior. You're setting the box to behave like a router by masquerading IP traffic. That's what will create a router. That's what we want. So we will do this in an actual step once we are ready for that. What I'm talking about is you have to create a segment and another segment. One of them will be a public segment. The other will be a private segment. And you need to create new machines here and here and here and some here. But most of them here, because that's where your applications will run. And that's what you want to protect these guys from bad people. And so keep them private. But at the same time, you need to have a method of connecting to the world outside, like Fox News. Actually, Fox is not the right example to give. I would like have them connect to the Postmark service, postmarkapp.com, so they can send out emails. I want them to be able to connect to some S3 buckets or some other update services from Ubuntu or open source applications. You want to update them. So you want to have these guys access these services on the internet, for which you require a router here. And that's what we will do, is we will build a router ourselves and put it right on the public area in our VPC and have this router connect pretty much like this. So all these boxes can then use the router to connect to the world outside. And here we would need a gateway. This gateway is made available to us in the cloud in form of what you saw before in the screen called Internet Gateway. That gateway allows you a connection like Comcast does with your cable modem. And the router will allow you to do masquerading. And then these applications can connect to S3 bucket or send an email through Postmark app or update themselves or things of that nature. So you need to create this kind of a setup. Now this is a simple but slightly more complex setup than the initial design that these guys wanted us to look at. If you start the wizard again, the first example is a single public subnet. This public subnet is a bad design. Simply speaking, that's not how most companies run. They will typically run a private and a public area separated. There will be a private subnet and a public subnet clearly called out and designated with a range of CIDR block here, so that you will know what you're talking about. And then you get machines here and here and here and any number of them, and one machine here. And then either you convert that machine into a masquerading router so that you have a router, or alternatively, when you don't want to go through the job of creating a machine, converting it into a router, you get a ready-made router. That is also possible, by the way. A ready NAT is available in Amazon. You can use that box and just it becomes the router. It is actually a NAT. So you just have to get the right machine image and then load up a machine with that image to it becomes a router, because it is designed like that. It is designed to contain this code. We'll run this code later on, but it's pretty small. And I'll paste this code for you to examine and review and run it yourself. And you can play with that for example, in a VPC, as we will discuss. But this is not the idea that I want you to use, because this is, I think, a silly design. So skip this one. This one is more reasonable. In here, we have a public subnet and a private subnet. And you will see that the private subnet contains lots of machines. Public subnet contains some machines. You can have more also, but just saying some. And one or more of them have been configured as a NAT, which is router function, which is the function in router that we are interested in, is masquerading NAT. And then you connect them appropriately, like demonstrated in the picture. We'll connect them ourselves as opposed to using the wizard to run it. We can click the select button and just click the blue button and we are done. But that's not what I want. I want to understand. So we are not clicking these easy buttons. There are more choices. We'll discuss these guys later. But I want to begin assembling components needed for us to create our own VPC without using the wizard. So what do I do now? I ignore that blue button, and here I go to your VPCs. And there I have the leave it alone, do not disturb, don't bother default VPC that is marked as a default VPC, yes. So I'm not touching it. And please remember to not delete it. You can delete it, but don't delete it. Instead, create a separate one. So I'll say create a VPC. And let me tell you, creating a VPC itself does not cost you anything. It is free. It doesn't burn any CPU cycles for Amazon. It is just a allocation of address space, practically speaking. So it doesn't actually cost you money to create a VPC. And it has to have a name. So we'll give it some name, like this name. And then it has to have a CIDR block. They give you an example right there. And they tell you that you cannot specify a CIDR block more than or bigger than this number 16/16, meaning a bigger number can be something like, a bigger number will be something like 10,000/15 will be bigger than /16, right? So 8 is even bigger. You cannot select line 7. In Amazon, the maximum size of a VPC is only line 6. It can have only these many addresses. That's the limitation. That's what we got. That's the maximum size of a VPC as limited by Amazon's design. They tell you right up front here. It says you cannot specify IPv4 CIDR block larger than /16. Okay. So we understand. We are also skipping the IPv6 CIDR block right now. Not selecting that currently. We'll discuss that later on. For simplicity, I want to just stick to IPv4 and then understand that I want to provide a CIDR block here. And I will say, okay, here it is. So I select and I allocate this address space as the private address space designated for my CloudGenius VPC. And I select the default tenancy as opposed to dedicated tenancy. A dedicated tenancy means that the machines that they will create for me will only be hosting the machines for my company and no other company. In my account, I need the whole box for allocated for me, dedicated for me, and that basically leads to higher price machines. When you create a machine, the machine will be expensive because it will be dedicated tenancy. So you may not want that. Maybe it's a good idea for your business, but for our example purposes, as we learn, we don't need to have dedicated tenancy. So we'll go with default. When you run an actual application in the cloud for a customer of yours or for your employer, you want to make that decision very carefully. Whether you want dedicated tenancy or default shared tenancy is okay. For our purpose, default is okay. I think it's the right choice. So I create, and then we are done. This creates a VPC, but it doesn't have any components to begin with. So it's just a skeleton allocation of address. You can see the CIDR allocation right there, but then it has nothing else. So now let's walk through the item by item right here on the left side here, and see we have any subnets. Apparently we do have 3 subnets, but if you now look at, they all belong to the leave it alone VPC, and I want to really leave it alone. So I will like to filter and say filter by VPC and click to select only the CloudGenius VPC. And now I see only one VPC, which is this one. and I see only 0 subnets, which are these ones. I don't have any. In fact, I will see nothing because I have filtered by VPC. If I remove the filter, I get the subnets back, but I'll stick my focus to the CloudGenius VPC like that, and I see nothing, empty. Now here, I begin to create subnets. What a subnet is basically a subset of this address. This is a subset. This is another subset. This is another. And here is another, and so on. These are subsets. Line number 9, 11, 13 contains total of 5 subsets of the big subnet 6, line 6. These items below this line are subsets of the line above. You can understand why I mean they are subsets, because the number 24 is a smaller size compared to 16. This is a bigger subset, a bigger address space. These are smaller segments of the big space. They belong in the same CIDR. These are all babies compared to this guy. So these are examples of CIDR that I can choose to create a subnet, and then I can allocate these different ways of creating. You can choose any number you like, actually. These are just my current choices. And you can vary this number out here. Like, for example, the third byte. Like, I can change this, or I can change this, or I can change this, or I can change this number 33 or 55. I can vary it according to my preference and allocate subnet 1 or subnet Rainier, or you can call it whatever you like. You just name them, subnet Poland, like that. It's not going to be in Poland. Just by the name I chose Poland doesn't make it go Poland. It will still stay in my region of choice, which is Oregon, but I can name it Poland. That's irrelevant. Names are irrelevant. What I'm really going to do is create a address space, and I'll allocate that, and not in the leave it alone, but in the CloudGenius VPC. I want to create a CIDR block subset like this, and I can give it a name that is more reasonable than Poland or Rainier. I will call it private or call it public. That's just another name, right? You can choose whatever you like. These are just names. Just by having the name public doesn't make a subnet public. That's another thing to remember. Just because I named it public doesn't make it public. There is something very explicit about making a subnet, a subnet like this public or not. It really depends on how you connect the wire. And I'll show you how to connect the wire without going to Oregon, just sitting in the browser window. We can actually pinpoint and exactly hook up cables without doing anything like that, just figuratively speaking, but it actually is what is going on under the hood is known as software-defined networking. That's what's going on under the hood. There is this buzzword of SDN that you can read more about, but I'll let you read SDN. That's what we are really playing with right now, is defining these subnets, defining routes, defining routers, and creating a virtual private area for us to use like a virtual private network. All of these things are network capabilities that come generally known as software-defined networking concepts or networks, to be generally speaking. We will be able to hook up certain cables, figuratively speaking, and connect one item to the other and make sure that the traffic flows and make sure other traffic is prevented. Certain things work and certain things do not work because that's how we want it to be. We'll be able to do those things. But right now, just calling out that we are creating a subnet, merely naming it to be our public subnet. But just by the fact that we label it public doesn't make it a public subnet. So I'll label it for right now, I'll call it monkey. Yeah, that's the name. So it's a monkey subnet, which has this CIDR block, and I create, and it is on my CloudGenius VPC. So created. So I have this monkey subnet created, and it should take a few more seconds and finish. So here we go. Created a subnet, and I intend to convert this monkey into a public subnet, by the way. So I'll change the name later on, but I'm just telling you my intentions. I'm just deliberately named it monkey so you understand that names do not matter. What matters is the way you connect. So another subnet, which I intend to use like a private subnet. So this one, I will call it Tiger, and choose the correct VPC. And here is my CIDR block selection. So I've chosen this as the monkey, and the other one I want to choose as Tiger, and remove the others, just 2 subnets. So that's the CIDR block I want to use. So I'll copy that, take it here, and paste it right there. Boom. Now I had a Tiger subnet, and create in the CloudGenius VPC. So create. So now I have 2 subnets, monkey and Tiger. What does it do? Nothing, except that they're just address allocations. They are address allocations 10.0.0.0.24 and 10.0.1.0.24 for Tiger and monkey, and that's what you have. So let's go design this in a pictorial form. What we now have is a address space allocation of 10.0.0.0/16 for the entire VPC, and in there we have 2 addresses, the monkey address and the Tiger address, and this address space is 10.0.0.0/24, and this address is 10.0.10/24. That's what we got. Now I want to make this public and make this or keep this private. By the way, right now both are private, they're not connected. So I want to make the connectivity go, or rather happen. So for which we need a way to define our routes, how the traffic flows. That idea of routes is defined in a table, literally that looks like Excel spreadsheet table, pretty much. And that table is what we are going to create in the route table section. We have one route table already given to us. And since it is given to us by default, I don't want to use it. So I'll say ignore this. Just ignore. Don't delete, leave it alone. Next, I want to create route tables for me to allow a method of connecting traffic between the monkey and the Tiger and the world outside. I would like to define these routes so that traffic will flow according to the route table that I will assign. So for every subnet like this and this, I will need to have a route table. I will need to have that table defined so that it will dictate how the traffic will flow or not flow. I want to control that. Now, before we get to the route table thing, we need to get a service provider to give us a connection through a gateway called IGW, Internet Gateway. This is like going to Comcast and saying, hey, can you give me internet service, please? So they will give you. You have to pay them money, except in case of Amazon, it is free. You go to the gateway first, and you don't find any because they are hidden, because it's on the leave it alone subnet, sorry, leave it alone VPC. We have a gateway attached, so we are not focusing on that. Instead, we are focusing on the CloudGenius VPC, where we do not have a gateway. So we create one and call it the Internet Gateway for my CloudGenius VPC and create. So I have it, and it doesn't show up. So I'll remove my filter. Now it shows up. I'll select that IGW gateway and attach it to my VPC CloudGenius and say, please attach, like that. So it is now, refresh please, attach it please. No, not attached. Okay, attach it to the VPC, this one, and please attach. It is already attached. Fine, then show it to me that it is attached. Okay, refresh. So it should show us that it is, what's going on? I thought it's attached. So it says detached when I attempt attachment.
Browser is caching. So
I
leave the
know, I know, I
page.
know. This is stupidity. Yeah, I understand. So,
Masquerade.
yeah,
Refresh on the upper right.
so open a different browser. Yeah, we'll fix this. So we'll open a different browser and go to Amazon console. console.aws.amazon.com and login. Come on, login. Load. There we go. So it loads and I log in and then I save my password and then I put my token and then I sign in. So now I'm signed in. I go to my VPC. Come on, VPC, where are you? Here. And in there, I find my gateway, and the gateway is not attached to the VPC. Okay, come on, please attach. So let's read this. It says already attached to what?
Can you just delete it and then recreate?
I know. I'll just ignore.
No, it's look at the number. I think it's attached to a different number.
Let's go read.
It's attached to IG resource is already attached to network 726 CBD.
It's not even mine.
So
Exactly.
try using something besides IGW. Delete this and use different prefix. I am flattered.
And now it's attached.
Yeah, as soon as Alexi shows up, it fixes itself, right? Just the mere presence of Alexi.
I think that's a bug.
What can I say? No, it's me. It's me.
Even Alexi, right? Alexi fixed it. Just by the fact that you remember the name Alexi, it is like magic. It fixes it. Okay. Okay, fine. I think it was a transient problem. So yeah, we ignore that. So we'll leave it alone as we have. So we'll ignore, sorry, I don't want to ignore Alexi. So I'll just,
How did you tell it to attach in the first place?
yeah, I don't know how it just magically attached. So I'm going to attach the Alexi VPC to Cloud Genius and delete the IGW right there. You go, bye. And so I'm deleting the IGW. We are using Alexi. There we go. So now we are connected and we drop down, select the Cloud Genius VPC. The name of our service is Alexi, which is our internet connectivity service. And now we are back in business. Now this is the gateway. We just established this IGW is called Alexi now. So the Alexi provides us internet connectivity worldwide. Now that is a necessary element for us to construct our route tables. We need them. We need Alexi to have a method to connect to the internet or not connect to the internet.
I will do it manually.
Right. So what I want to do is I want to make sure that the boxes I create here in the monkey subnet should be allowed to connect through Alexi to go outside. That's how I should write my route table for the monkey subnet. Whereas in here, I will create machines T1, T2, T3, the Tiger subnet. I want them to not connect to Alexi at all because, you know, it is public internet. So I don't want them to be connecting. But I still want these T1, T2, T3, which are in the Tiger subnet, to connect to the world outside some other way, like, for example, using a NAT, like network address translation masquerade device known as router. So I would like to have a router created or ready-made. I use it and I'll create or use a ready-made router here. Like this, I should call it R. So that's my router device. I would create that device, probably use a ready-made for first time and then create our own next time. But these functions belong in this box. And what I want to actually connect my routing table in a fashion so that it is very, very clear is that anything that these T2, T3, these guys, T1, T2, T3, they should connect like this. And router should connect to Alexi. You connect to the router, you also connect to the router, and router connects to Alexi and then go out. That's how it should be written. That's how this route table should be constructed. Whereas this route table here will be a different RT and it will ignore your router. It will say, machines here, M1, M2, M3, and the router machine, all of these guys should connect directly to the internet through the gateway. That's the idea. So how do you then actually write these route tables? As I said, route tables are basically an Excel spreadsheet, like simple table, like 2 by 2, things like that. So you have to make that association between an association between this table and the subnet, and also this table and the subnet. This association has to be clearly made. Otherwise, you have no idea which belongs to which. So this association has to be made. And then the actual route has to be defined. Those two are the components that go in constructing a route table: the association with a subnet and the actual route. Let's go do that piece. So here we are now going back to the subnet section. We saw these two subnets, tiger and monkey. And now that I have clarified the idea that this tiger actually is going to be our private. It's just a name. The actual connotation does not come by the name, but by the fact that you define a route. So this is going to be our public subnet, just renaming them back to what I intend them to become. And then I go to the route table section. Here I have this ignore this functions. I'll ignore this actually and create a new route table. Now this route table, again, the names do not matter, but the way I map them and associate them and actually define the routes is what actually dictates. So first I will create a public route table and create it in the CloudGenius VPC. So it is creating right now, and it showed up right there. Now if you look at carefully, I want to associate this with a subnet. So I had to call out a subnet association between this public subnet. Sorry, I have to be very clear in the way I speak. So what I'm saying is I want to associate this route table with this subnet. That's what I really want to do. So I will edit this and say, I want you to associate yourself with the public subnet. Save. When I do that, I find that my route table ID is associated with the correct CIDR block, the correct subnet ID. That's the association part taken care of. Good. That's one piece of the puzzle. So now I know that this RT is associated with this route table, which I have renamed as public. Next step is to actually call out a route in the routing table. So we'll say routes. What is the route currently defined? Let's go read. Currently we see that the destination can be 10.0.0.0.16. What does 10.0.0.16 mean? It means the entire VPC. Not the entire internet. The entire internet means this. So line 6, entire VPC is the destination here. That one. Basically, you use the local connectivity inside the VPC, and any traffic, as long as the destination is 10.0.0.0.16, it's active and you're okay to connect. That's the routing table definition. It also, by definition, means that you can connect to anything as long as it is inside the VPC, but then that's all. You cannot really traverse to the world outside. So we want to expand our table. We want to create one more entry that allows people, or rather machines, like the machines on the public subnet, to go to anywhere on the internet. So I will edit this table and say, add another route, like that. And here I will say, go anywhere you want on the internet, 0.0.0.0/0. And by the way, in this discussion, this is the most critical part, hard to understand for most people, but according to my observation. That's why I'm slightly slowing down right now. I find that this is the hardest part in the exercise to comprehend. There's one more block, one more stumbling block that people stumble on that I have seen from my past experience. So pay careful attention to this idea of adding another route. This route allows you to go traverse to anywhere on the internet, like I mentioned here, 0000/0. But then you need a method of connecting. That method of connecting, thanks to Alexi, is available right here in this window. So we'll go and click there, and we find Alexi right there. We just select Alexi like that. So delete, Alexi selected, and save. The moment you save, you have now a route to the internet using the gateway you have chosen, which is the Alexi gateway. Now you have successfully established a route to anywhere on the internet through the subnets, through the routing table that we have defined right here. And this subnet, called the public subnet, is now associated with the routing table, which shows you can go anywhere on the internet using the gateway that we now have. That's the public guys, public subnet. The machines that are created on the public subnet, like these and these and these guys, they can now connect through Alexi to go outside, because that's what we defined in the routing table, and associated this table with the subnet. I think the picture has gone too dirty, so I'll draw it again and change my ink. So we have the machine, or the router machine, and other machines here, M1, M2, M3, like that, in the public subnet, and the corresponding route table allowing us to go outside using the Alexi gateway. And this is associated, and they can just go out because that's the route defined, and that's the piece, half of the puzzle. Now the other side, we still have our private tigers, Tiger 1, Tiger 2, Tiger 3. They have no way to connect because their route table is not defined yet. So let's go define a route table for them. And here we go. So we'll say route table. We have only one route table, the public. We'll create one more and call it public. And select the VPC, the CloudGenius VPC. And this is not public, but private. It should be labeled private because we are doing for the tigers, the private subnet. So private, create. It's created. Just by creating, nothing happens. You have to explicitly associate that with the subnet that you want, 10.0.1.0, like this. You want this to be associated with line number 10, this one. That's what I want to do. So I will edit my association and say, you associate yourself, the private route table, you please associate yourself with this one. So I select that and save. So the association is now established with the line number 10 in the picture, like this, associated. This new route table called private is associated with the subnet called private. That association is half the solution. The other half of the solution is to allow these boxes T1, T2, T3, which are on the private subnet, to connect to the entire internet. But we don't want them to connect directly, just like these guys go through Alexi. That's not what we want. We don't even want this connection. What we rather want is them going out through this router, like that. But we don't have the router yet. So we cannot really complete this step. Not yet. Only half of it, the association part, we took care of. And let's go examine what we have in that. So in the route section, we have a route anywhere on the VPC is okay to connect. But then if I edit and say add another route and say that, go anywhere on the internet, I can, but then it gives me the only choice available is Alexi. But I don't want to select Alexi. That's not how I want to wire up. So I'm not selecting anything. So I'll say remove this one and do nothing and cancel, because I want to get the gateway device, the NAT device first in place. that NAT device needs to belong here on the public subnet. So I need to go and find a way to get a NAT. So I'll go to Amazon and say, by the way, I'd like to tell you that Amazon has recently introduced a simpler solution to doing what I'm going to do, the difficult route. The simpler solution is to spend money and get this ready-made solution. And if you click this button, you get a ready-made solution. It just hooks up everything, and it's another gateway, the NAT gateway. That's a new solution set available these days. It's not free, and it is slightly more expensive, but it will do a whole lot of things for you without you understanding what's going on. That's not what I want to do, so I'm not using this. There is this choice available. You can use it. You actually should use it in production. But my goal is to not just make it easy, but to actually make you understand. So I'm not using this gateway, ready-made solution. Instead, I'll create one myself. What I'm trying to accomplish is I want to create this router device, actually get a machine, load it up in the public subnet, and then use it in my route table here. That's what I want to accomplish. So we'll do that. I will go to EC2, where I get machines. And I don't find anything right here, right now, ready as a NAT. So, yes.
Real quick, could you show me how you associated the subnets again?
Okay.
Mine didn't seem to save.
Yeah. I'll go back and show it to you. So back in VPC, and the association is in the Cloud Genius VPC route table. Select the private subnet association, edit, and associate.
Oh, got it. Okay, thanks.
Cancel all the way back to a different page called EC2, where I want to create a new box. That box becomes our NAT. So you want to launch an instance and you want to find an instance, but then you don't find it easily, right? That's a challenge. Amazon, it's always a challenge with big clouds. It's hard to find. So we'll go to the community AMI. That's where people have created AMI, Amazon machine images, ready for us to consume. And then you have to search. There are like 50,000 images available here. So you want to search the right one. So we'll go search. How do you search? I know what to search, so I'll just tell you what to search. The easiest way to think about is that I want to get a NAT device. So I'll just type NAT. And then a shortcut is to use Amazon's ready-made image. So I'll say, okay, search this. So I get some answers back. I get 46 results that contain NAT and Amazon. So I'll narrow it down with the date. So we are looking at 2017, September 2016, maybe the 17.9 is a good one. So this is like 2014. This looks like a good later image, so I'll use that. So that's how you select. Just search for NAT Amazon and you will find an answer. And we'll pick the answer and select that machine and say T2 Micro is a good one for experimentation and it is also free. So we'll just go configure the details of the instance and watch these things carefully, because this is going to involve a little bit of subtlety. We want to make sure that our machine that we are creating right now actually goes and sits right in this location in the public subnet in our VPC, not any random location. So we want to be very careful in picking the exact destination. By default, it goes to the default VPC. I don't want the default VPC. I want to select my Cloud Genius VPC. So I select that one. Then I will select drop down and say that I want to get this machine in the public subnet, not the private one, please. So give it to me in the public subnet. And I actually want to get a public IP because this is going to be my router box and I want it to connect to Alexi. Like Alexi, I want to connect to Alexi. So I want to say, please give me an IP address so I can talk to Alexi. This is the router connection right there. So you want to enable. So when you say automatically assign a public IP, the default answer is don't. Disable is the right, disable is the default choice. If you don't pay attention, you will not be able to connect. So make sure you pay attention here and say enable. Similarly, you have to be careful and select the right VPC right there. the Cloud Genius VPC, as opposed to the other one, which is the default, which is not what we are touching, Cloud Genius. And then public and private, two choices. You want to put this on the public side, you want to get a private public IP enable, so explicitly call it out enable, and then rest you can for now ignore. You can go with defaults. These three settings, network, subnet, and public IP settings, are carefully selected. Everything else we can just move forward. So add some storage. We don't need to store here. There is this magnetic choice that I get because my account is like 8 years old. I still have this choice. I don't know whether you have it or not, but don't use magnetic. Use GP SSD. It's the same price. Magnetic versus GP SSD, same price. So choose GP SSD. Don't have to go this higher performing SSD right now. Not for the NAT. We don't even use the disk. So what's the point? So just use GP SSD, add some tags, and actually don't. You configure security group. Now comes the idea that we have discussed in the past a little bit before, is to create or select an existing security group. So what I want to be able to do right now is to choose a select security group for ourselves. And I would like to call this security group my NAT group. And this is the NAT security group because it is a dedicated security group I want to create just for the NAT machine. So here we go. And I will open up some ports. For example, allow me to connect to the NAT right now. And I'll expand the ports later on, but I'm just creating a new security group for the dedicated purpose of use with the NAT machine that I'm creating right now. I call it NAT security group and adding just the SSH rule from my location. That's it. So I'm limiting it to myself right now. And I proceed to review and launch. And then I have to proceed the launch button. Then I have to select a key pair, which I think I have. I hope I have. I hope this key is the right one that I have because I keep deleting and creating new keys every single time. So, okay. What I would like to do is take a bet that this is the right key that I have in my machine. I hope. And so I'm going to choose that key, which I seem to have in my virtual machine somewhere. So I'll start that VM. I hope I did not. Let me just quickly check the VM if it is the same or not. I can tell. And if it is the same key, then I can actually use the key to connect. Otherwise, I'll be screwed and without a way to connect to my own NAT machine. That's going to be a problem. And so I'm waiting for the machine to start. But in the meanwhile, I'll describe some of the concepts. Like, for example.
Quick question.
Yes.
I'm just trying to follow along, and I'm back on your searching for that NAT image.
Uh-huh. Okay, I'll go there with you. So NAT Amazon.
Yeah, how did you get to that Choose Amy site?
Yeah, you just go back to the home, go to EC2, and then start a machine and launch a new instance, and then Community AMI, right there.
Got it. Thank you.
And then search.
That's what I was looking for.
Yeah, yeah. So now I have this machine running up. I would like to make sure, double check, cross. Yes.
This is Rob. You went really quick on making that last section for launching the machine.
Okay, I'll do the whole thing again. And now that I have
not the whole thing. It was just that last page where you were doing that.
Got it. So, but before I do that, I want to double check my key is in good shape or not. So I'll grab this public key like that, copy it, and make sure that it is the right key with Amazon. So that's the critical step I want to make. Otherwise, I'll be, creating a machine and unable to connect. So I'll go back to my key pair section and import a key pair and give it a name, and maybe give it a name different and paste and say import, and it is the same fingerprint. So that's good. So I have the key. Now let's go to the dashboard, create an instance, and then create Community AMI. And this is the repeating step. So NAT search for Amazon NATs, select the 2017 September NAT, select. Now select T2 micro, the cheap machine type, configure details. Now here I want only one NAT device. So I select number 1. In the network, I want to choose the Cloud Genius VPC, this one. I want to select my subnet to be not the private, but the public subnet. And then I want to assign a public IP address. So I will select this and say enable. These are the three things that are necessary: the VPC selection, the subnet selection, and ensuring that you are indeed getting a public IP. This will help you connect the NAT device, the router device, to Alexi gateway. Without this, you cannot. Then we proceed to add some storage. I don't want to use magnetic, so I choose GPSSD. You will probably not see this screen at all. Next, I'll add some tags, and I'll skip tagging for right now. Go to security groups, and I'll select to create a new security group by the name NAT. And description is also NAT, allowing me to connect through SSH through my IP address. And that is my security group definition. It is very narrow right now. I will expand the definition later on. It is very narrowly focused, allowing me to connect to this NAT machine from my location, which is 73, whatever that, /32. See that /32 right there? That's the CIDR block of one IP address for this location. And so I'm reviewing and launching, and I launch. And when I say launch, I choose an existing key pair. I have my key pair already there. It is the same with double entry of the same idea. While selecting the IDRSA key pair, I acknowledge that I have the corresponding private key. I confirm that one more time by listing out my private key is right there. So I know for sure. And then I say, okay, launch the NAT device. Thank goodness, launch the NAT finally launching right now. So we're launching. We see that this machine is now getting ready. It is in a pending state. And now comes the idea of telling you the fact that there is this unique thing about Amazon that you need to do in order for this NAT to function like a NAT. And if you don't do this, you will find that the NAT is not functioning like a NAT. You want to allow NAT to be able to masquerade. That masquerading will not happen if you don't do this following one step. That step is called source destination check. This is currently true, and you want to make it false. And you can do that. Actually, you need to do that only for this machine, only for the NAT machine, this machine called the NAT or the router. Only for this machine that you have to make this setting false. The source destination check, you have to make it false only for this one machine. If you don't do this, the poor NAT will not be able to function like what it wants to, like masquerade. It will not be able to do that. And therefore, right click, networking, and change source destination check. And here you want to disable. You want to say, yes, please disable the source destination check. And by source and destination check, what it does is the network in Amazon will actually make sure that the traffic it is originating from is actually coming from the same location. But that's not what happens in case of NAT. It is actually going to lie that I am the other guy or the other machine. So it is going to be pretending to be somebody else. And this check, therefore, has to be disabled. Source destination will be different. And the fact that I just did it false allows it to behave like a NAT. Now that we have this behavior ready for us, we'll go back to our VPC. Right there. Look at our subnets and our route tables. And we have to filter it down to the CloudGenius VPC. And now we have the route table, the private one, which has a subnet association with the private subnet, but doesn't have a route to the internet yet. And now we expand. We say add another route. And here we say 0000/0. So let me connect the machines T1, T2, T3 in my private segment, these guys. I want them to connect not directly through the Alexi machine or rather Alexi gateway, but through this new NAT device that I just created. That's what I want to do here. So I'll say, okay, anywhere on the internet, the destination is, but the target will be not Alexi, but NAT. This just showed up because we have a NAT now, and it is going to function like a NAT. So we create one and select that and save. And now it is successful and active. Now, having done this part, what you will understand is that these boxes, when you connect them, create them, and right now they don't exist. Right now we don't have M2, M3, M1, don't have them. Right now we don't have T1, T2, T3 and all that. All we did was just create this box and defined an association and defined a route so that this machine that we just have started, by the way, has this route directly to go through Alexi to the world outside. And these machines, when they will get created, rather I should say T1, T2, but that's just a name. So whenever these machines get created, they will go through the NAT device, the router device. I'm calling it NAT. So the same device. That's how I want the traffic to flow. Okay, now this structure, kind of bare skeleton, ready for us to consume. So now let us first thing connect to the router. Can we connect to the router? I think so. How do we do that? We go to the machine, grab its public IP address, and I'm expecting that this running instance, which is our NAT machine, the router machine, has a public IP address because we wanted it to get one, and we got one, and it's right there. So it has the public IP. We copy it, bring it here, and connect. I know that this is the Amazon Linux machine, so it is not Ubuntu. So what is it? It is going to be EC2 user. That's the documentation. So we get the IP address and then say, okay, take my public key from here and please connect. And we expect it to connect, and it does connect, and it did connect. And now I'm currently connected to the Amazon Linux. And you can see that it is based on Red Hat Fedora. It is Amazon Linux, and I'm connected. This is the NAT machine. Let me tell you that you very, very rarely actually connect to the NAT like this. That's not how you actually do. So I'm going to exit. Just leave it alone. It's our NAT box. You don't connect to your router like this, but you could. So we did. You don't want to. It's just that I wanted to test. That's fine. Now comes the actual machine that I want to create somewhere out in the back. And I think we have some, how much time? 39. So we have 20 more minutes. So we can do something meaningful. Okay. So what I want to do now is, get some machines going here on the private subnet. Let's clean it up and draw it again. So this is a subnet, this is another subnet, there's a route table here, there's a route table here, and I have a router here, and it is connected to the Alexi gateway right there. And all is good up until now. From my location in my home, I am able to connect to the router directly because the security group that I created for NAT allows me to do that. So it permits me, so I'm able to connect to my NAT, but that's not how the dominant usage is. It is different. We actually want to connect to these machines that I will be creating now here. I want to create machines over there and then connect to them. So we'll create some. We'll go there and put a new machine, this time not in the public area, not here, but here. So we'll do them. We'll create them right here, right now. So there we go. Go there, launch another instance, this time Ubuntu. T2 micro is good. Configure the details. Excuse me. One instance to begin with. Leave it alone is a bad idea. I want to choose the Cloud Genius VPC. And I want to get the private area. That's where I want the machine to be created. So select private. And then use the subnet setting. The subnet setting is to disable getting me a public IP. I don't want a public IP. Don't want. So I'll say disable. Or you can just leave the default alone. Either way is fine. It's the same thing. So I select disable to be explicitly clear about it, that I don't want a public IP address. And then I add some storage, and I get 8 GB storage is good enough. So I add some tags, and I configure security groups, and I create a new one. The security group will be called my applications. And in there, in that security group, I would like to create some permissions for me to be able to get in, SSH and TCP and 22 and my IP address and like that. And so I just temporarily putting this one entry. I will expand on it later on. Later on, I will excuse me, I'll expand the security group later on, but right now, just one entry. This security group will allow transport among the application machines that I will be creating in the private area. And now I'm launching a new machine containing Ubuntu Server 16.04, and I launch it, and I say use my existing key pair and launch. So it launches. It is pending right now, and you will see that this machine is not going to get any, let's call it the application server. So this app server is not going to receive a public IP address. Not at all, because we said so. Excuse me. It is initializing, and I think it should be ready. So what do we do with it now? How do we connect to it? That's the question. So we have this machine out here running my application. It's a Ubuntu box. I created it. I don't have a public IP. So how do I go there? I mean, I want to connect from my home here, but there is no route. So what do I do? There is no public IP. What do I type? Private IP? It will not resolve. I mean, there is a private IP right there. I can see it, copy it. But if I connect to the private IP just like that, it is going to be connecting to a machine in my home, because that is also my home address space. So what do I do now? How do I connect? That's the challenge, right? Anybody has an answer to this? Like, what do I do now? I want to connect there, and I just created a box and put that here. Now I cannot connect. So what was the point of me telling you all this?
There was a public ID entry.
Sorry?
There was a public ID somewhere in configuration, right?
No, I chose to not get a public IP address. I deliberately chose that. I told it, don't give me public IP. And
Right.
therefore, I don't have one.
So you're going to connect to your NAT.
Yes, you can connect it to the NAT, but then what?
You're going to have it masquerade as your app and push itself out through Alexi.
Correct, that's the outbound route. Like outbound, fine, it works. That's okay. But it is me originating traffic from here.
Oh,
I want to inject, I want to go in.
You connect to your router, and then from the router connect to the application, the app server.
Right. Now there's a security problem with that idea. The security problem is that you have to put your private key here. Right? If you're sitting here and you want to connect to this machine, you can, but you need to have your private key on that box, and that's
So are you going to set up? Are you going to set up SSH forwarding then?
Yes, indeed. And so we want to actually use SSH forwarding tunnel and jump from the box here to the box here. And that jump is defined in an example that is available to us in this folder. That's how you jump. So this config example is the file which we want to use as an example. We'll modify this example and use this SSH forwarding agent and proxy command to do an SSH forwarding jump step. Let's go read this in simple terms. So we'll open the Atom editor and edit these files. For example, we have the example file here. And so I want to rename that file, or rather copy it or duplicate it, and duplicate it by the name. Remove the example part, just config. That's the name I want. And here I want to change the name, or rather this IP address that I have is kind of an example address. That's not what I want. What I really want is the NAT's public IP. I want to put that right here. This is not the right value, by the way. This is like 126 and 10, which is not the answer to my NAT has a different IP address, which is this address. So let's copy that NAT public IP address and put that in this location. In place of the number that we have, we will put the right value right there. And it goes like this. So now we have changed the host name, which actually is the IP address for the machine called NAT. And we put the IP address right there. I want to make sure that our key that we are using is this name and in this location, which is already correct.
Is that a static IP address?
That is a yeah, let's be clear in terminology. It is not a static IP address. It is not elastic IP address. It is just a public IP address. A public IP address. In business, when you are running this in production, you want to receive a static IP address and allocate it to your NAT box. You should do that. In Amazon's language, Amazon calls static IP, they call it elastic IP. So if you talk to Amazon, you tell them, I need a elastic IP. So they will understand what you mean by static IP, because they will not. I mean, I'm just kidding. They understand. So I just put this public IP, which is not static. It might change on us, but yeah.
So can we use the DNS name of that that's shown there in the NAT image?
You can, but you know what? Let me just point out. I want to point out one thing, that DNS name is kind of tied to, by the way, I don't even have a DNS name. So the DNS name is tied to the IP address. So if you see the DNS name in Amazon, you will see that it actually is a representation of the numbers that you see in the public IP address itself.
Yeah, you're right. I see that.
Which means that this is more or less static, at least in Amazon, more or less. It might change, and so we don't know. But I think from production usage perspective, you get a static IP allocated to you from elastic IP addresses, which are available right here. Elastic IP, you allocate them and you associate them, and that's how you go in production. For our purposes, this one is okay. I mean, we can just use this for right now. So this public IP, I'm just using it right here. Where is that? Here. So I just saved that right there. And I'm going to forward my agents. I'll keep my identity file local to me, the private IP, sorry, the private key. And I know that this box that I have here in Amazon is actually an Amazon Linux. So the username is EC2 user. The box inside in the private area has a private IP, which is not this number. So let's go find out what that number is. And so we'll go to the application box that we have, and the private IP is this number. So we'll copy it and we'll bring it back to this location, and this not 192, but 140. So let's go paste it and save. And then you will see that the identity file is the same. It is stored locally right here. That file I'm talking about, the private key, it is the same key. Again, the key is sitting locally right here on my laptop. It is not in the NAT. It is not in this host. But I know that this host is using Ubuntu OS. So the username for that host is Ubuntu. Having modified my configuration based on this example that I chose, I will close the example. I'll close the config file, and then look at this known host file and delete all the entries in there. So basically I want to delete, as in move it to trash. So I'd like to move this to trash just to illustrate an example. So I'm moving the known host files to trash, and now I am ready to experiment. what I really want to do is, first thing, connect to the NAT box. And I can now use these names. So I'll say, okay, connect. So it says, are you sure? And I say, yeah. So it connects. And I connected. Great. Now I will remove the known host file one more time. This time, what I want to do is SSH connect to the 10.0.1.140, which is the internal box. And now suddenly, magically, you will see that I am able to route my traffic because I have a special SSH configuration that I called out like this, which has a way to connect and pass on my forwarding agent using the proxy command, which is what is defined in line number 9, is what I'm using here. And I'm just saying SSH. I'm not even calling out a username, just saying the IP address, and let's do that. So that's what I want to do. I'll say SSH IP address of the internal box. Where is the box? It is sitting right here. It has the address of 10.0.1.140. It is not routable from my location, but I have this custom configuration SSH config that lets me take a hop from my intermediate, which is this box, and then jump through a proxy command to the destination box. So it's a two-step SSH jump. That's what you will see as I run this command. So I'll say, let's check whether a known host file is dead. Yeah, known host is missing. Nice. I don't want the known host right now for a demonstration purpose. So I'll illustrate that piece. I will now enter the command right now. I'll say, okay. And here the first question, are you sure what are you doing? This is the NAT box apparently. Are you sure you want to connect? And I say, yes. So I say yes. And now what happens? It is now jumping to the second box. And it is trying to connect. And it is failing to connect. Do you know why? It is trying to, but failing.
We haven't set up NATs on the NAT server.
We have said what?
We have not set up the NATs protocol on the NAT server.
No, it is already there. I think that's not the issue. The issue really is about the reason I think I slightly briefly mentioned that I will come back later and change something. What I mentioned was about security groups. And if you now filter this by VPC ID, and let us see the security groups that we are interested in, not this one, so I want to ignore this. Ignore this. And I am interested in the application security group. And this is the NAT security group. That's what I'm really interested in, is I want to make sure that this group, security group, allows transport inbound coming from my home. But that's not where the traffic is coming from. If you look carefully, this traffic is originating from this box. Not the subsequent traffic that you don't see right now is that attempting to connect to the private area and failing because the traffic is originating from the NAT box. And the security group permissions do not allow inbound connections from any other location other than my home. My home is not represented right there. That's why it is failing to connect, which means I want to expand on this inbound security group definition for the application machines. I have the machines in the private area. So I would like to edit and say, add a rule to allow any traffic, or rather all traffic, as long as it is coming from not anywhere, but custom location, coming from the CloudGenius VPC. Or rather, we'll select we'll say coming from NAT. I think that's better. Coming from NAT. Let's go type the name NAT. So as long as it is coming from the NAT security group, you allow traffic. Any traffic and all traffic, provided it is coming from the NAT security group. That's what I want to call out right there. And I just typed NA, and it prompted the right answer for me as a selection drop down, and I select. So this is allow traffic from NAT. And here is allow traffic from me. Now this is unnecessary, so I deleted that. But I brought that up to begin with to help you understand what I'm doing right now. But that is not necessary. This is necessary because the traffic actually comes from the NAT. That's where the traffic originates from. So I'm saving this right now. Now I modified my security group definitions for the application servers here to include any and all traffic as long as it is coming from the NAT. And I just expanded this. Now let's see what happens. It was closed, but then we'll try it again. And it says, are you sure you want to connect to this 10.0.140? That's what it's asking me. And I'll say yes, and it will connect and all that good stuff. And it's connected to Ubuntu now. But let's do it again. Back, close. And now I'll delete that known host file one more time. Known host file deleted one more time, and we'll say connect to this 10.0.1.140. That's what I want to connect. So let's go do it again. Click. It says, do you want to connect to this box called the NAT device, whatever that IP address is? Is there where you want to connect to? And I'll say yes. Next one is a subsequent verification question. Are you sure you want to connect to this box? And I know it is the right box, so I'll say yes. So it's a second hop happening right now. And I'll say yes. And it connected. And it gave me straight to the Ubuntu boxes I have here in the internal location, and it is Ubuntu.
Question is, Alexei. So
Yes.
for any practical purposes, there are no other ways to connect to the application box but through the NAT?
No, there are many other ways. This is just one of the several ways. There are probably 3 other ways I can demonstrate. The best way for a corporate enterprise use is not what I just demonstrated. It's just a quick and dirty way of connecting. It's not dirty, it's quick. But it is not the most sophisticated way of establishing connections. From a corporate enterprise deployment perspective, we suggest using other methods. This is not the method, but this is a method which is totally fine.
I think you misunderstood his question. Right now, the way you have it configured, this is the only way to actually connect to that VM.
You're right.
Okay, that's what I believe that's what your question was, Alexei, right?
Yeah.
Okay, thank you for clarifying. And yes, at this moment, as you see the picture, this is the only way to go in. Having answered this, I will elaborate further the other thoughts of how to do a corporate user. Like now, this was a home usage scenario. Let's go forget this guy. Let's deploy a corporate enterprise virtual private cloud. The right way to do this is to establish a private connection between a large corporation, establishing a private connection to the back end. That's a possibility these days. It's affordable by large companies, and that choice is available somewhere in the VPC section. Where is that? VPC. And you can establish a connectivity. Where is the VPC? Open it, please. Click and go to VPC. And a company of a decent size can create a customer gateway, which involves establishing a border gateway protocol and identifying an IP address, a static IP address, giving it a name and creating a custom gateway. That's one portion. Another way is to establish a virtual private gateway, which involves, hold on, not this one. Where is the, I think they've changed something here apparently. VPN connection, so you can establish a Cisco VPN, a Brocade VPN, or your own open source VPN, like we'll do in another example. We'll use this VPN called OpenVPN, which is an open source VPN, and we will use this package, and we'll run it in probably the next time, because we already timed out, but we'll create a VPN setup that will allow a corporation to connect to these boxes, internal boxes, through a private VPN connection. I will be using OpenVPN. And that's what you're looking at. Now, before we close today, I want to tell you one thing, that even if you don't use a elaborate VPN method, it is a good idea to not use the router as a jumping point. Instead, leave the router alone and create a jump box, separate box just for jumping. That's a better idea. It's more secure. It leaves your NAT alone. Don't mess with it. And create a separate box that will let you as in here, jump like that to the boxes inside. By dedicating another box, you can call it jump box. You can call it bastion. Various people have different names for these same thing. You can call it tunnel machine. But practical idea is to avoid using the NAT. Avoid using the NAT, because NAT is supposed to be a dedicated purpose device. The purpose of that device is to let the traffic go from here to the world outside. That's the purpose. So you dedicate that box with that one purpose in mind and don't mess with it. If you want to jump and go inside and using the proxy command method, create another box. Use a jump box. And when you're done jumping, you kill the box. And then nobody can enter, even you. So if you want to again jump in, you create another jump box and you jump in and you go inside and do whatever you want. But ideally, once the production setup is deployed, you don't even want to go inside. I mean, you want to actually not have these boxes at all to begin with, because leaving them alone is a bad idea. You would rather not have any of these guys, because you don't want to be messing with production manually. In a subsequent exercise, we will create the whole thing like we just discussed today in a step-by-step. We'll discuss and create the whole setup in one command. Just run it. It builds out exactly what you want. We'll be using this tool called Terraform, which is a fabulous tool, open source again, that lets you configure and create whatever you want, whatever design implementation you want. Write code for that. It is simple to write that code, and you create whatever setup you want in almost any cloud. You can see the documentation. It has providers for all the major cloud companies in other clouds, and infrastructure software, network components, and a bunch of other feature sets. It's a fairly complex, elaborate piece of puzzle that has been solved in the open source, and all the big players are available. So you can use this and remain neutral and still benefit from orchestration of any design you want in any cloud of your choice. And we have exercises on this coming along. We'll use this one as opposed to the custom tool by every cloud provider. So Alibaba, AWS, Azure, and Google, and all these guys will have their own tools of configuring. But I don't prefer any of those. I prefer this because it is neutral and allows us to connect to any of the cloud services that we want. And it leaves us in our control, things in our control. That's what I would like to point out to you. And with this said, I would continue this exercise next time. But before I hang up, yes, Rav is asking about the masquerading tool. The masquerading script that I had in my script somewhere here is actually allowing us to convert a box that I will create here, like using Ubuntu, which is not a NAT to begin with, and then magically convert this into a NAT, as opposed to relying on the Amazon NAT. So don't rely on anybody. Use open source, Ubuntu, and convert into a NAT. So we're doing it ourselves as opposed to relying on their image. That's what I'm talking about. Now that a couple of last steps before I shut down. Is this Ubuntu box? This is how we connected. The other thing that I think I mentioned on the jump box already, this I described. And when we come along next time, I want to point out one thing is, if you now somehow decide that I want to kill my NAT box. So let's see what happens when you kill the NAT box. When you go here and you say my NAT machine should now instant state, terminate, and die. When the NAT dies, you now have no way for your application boxes to connect to the world outside. So this is shutting down, the NAT is shutting down. And if you now go back to your Amazon console in the VPC and look at your VPC called Cloud Genius, and in there, look at the route table for Cloud Genius VPC and look at the private route, and the subnet association is with the private subnet, and the route shows you that this thing is going through the NAT, but the NAT is dead and it still shows active. But as soon as I refresh, the NAT should be gone, and I should see that this Cloud Genius VPC and this route table called the private has a route which leads us to a black hole. This should say black hole in just a few. Let's go verify this, whether the machine is actually dead or not. As soon as the machine dies, the NAT machine, we should see a black hole. The machine is died finally. I think so, terminated, which means our item here should actually be showing a black hole. Let's go refresh one more time to see it. And I want to see the black hole before I stop recording. So Cloud Genius VPC in the public route should show a black hole. Now that black hole basically means any traffic originating from the application servers, which are on the private subnet using this private route table, which has a route to anywhere on the internet, which is not really connected to anything because it is a black hole, because the box itself, we exploded it and it died. That's the idea behind the black hole. So basically you want to remove this entry. It is kind of pointless, and save. I'll leave the setup like this, and we'll continue our exercise next time. I'm not messing with any setup. I'll leave it alone. We get together again on 24th, which is a Wednesday. And I want to, before I hang up, a couple of people, more than a couple, have actually asked us to get together informally. And many of you have asked that we have coffee or something. I welcome that. What I'm also suggesting is that you come up with a date on which we get together and grab a bite or something. So maybe we go at a place to eat. I know many of us are here, but like not everybody is here. So I am already sorry for those who are away from us. But for those of us who are here, I'm suggesting either this place, Haiku in Redmond, or Dough Zone. So Haiku is a good place where I think beautiful Asian food. Another one is Dough Zone that we want to grab something to eat there, get together. That's what I'm suggesting. Let you pick the destination, let you pick the date. And my date suggestion would be like a Tuesday or Thursday, 5 o'clock, 4 o'clock, you choose, whatever time is convenient. So please Slack chat, let us know what's your preference. Haiku Sushi is a good one. We had a get together last time when we had a boot camp. And let me know. I'm stopping to record right now so that we don't record unnecessary conversations. So here we go, stopping the sharing. No, not stopping sharing, just stopping the record. Where is the record stop button? I guess I have to stop sharing. And then stopping the record now. And please